It's a moment when the music stops and I show up. Hello again. Thank you all for joining us for the second edition of HashiTalks Build. It's so amazing having so many of you in the chat, so many of you on LinkedIn, on YouTube. While you're here, while we get started with the housekeeping and everything, why don't you let us know where you're from? Where are you joining us from today? Personally, I'm in Amsterdam. It's very hot here right now, so yeah, definitely t-shirt weather, which is great. But we're here to learn about some cool stuff that we can build with HashiCorp tools, specifically, well, pretty much everything. There's too much to throw into a 15-second segment. Before we get started, though, a couple of housekeeping rules. While this is a virtual event, it is still a professional event, so we have a code of conduct, which means when you chat, please do, definitely chat, but when you chat, be respectful, be kind, and considerate. If you see something that you think is not okay, let one of our moderators know. We're also actively watching the chat, but it doesn't hurt to call it out. We're here to learn with each other. We're here to learn from each other. And if it's a safe space, we'll all actually learn in a very nice way. So with that, if you need the longer version of this, head on over to hashicorp.com/community-guidelines. We'll also have that in the lower third of your screen. And otherwise, I think we're ready for our first session with Kevin Wang on a 30-minute session on zero to serverless with Waypoint.
Hey, my name is Kevin, and I work on the digital web platform team here at HashiCorp. My focus has been on version docs, but today I'll be sharing with you a relatively new plugin for HashiCorp Waypoint called the Lambda Function URL plugin. I'll showcase how easy it is to containerize and deploy several web frameworks in various languages and get a nice publicly visible URL up and ready in a matter of seconds. Here are a few points that I want to highlight up front. I'll be using an existing Waypoint server, so I won't go over server setup. Some prior understanding of Docker will be nice to have, but not crucial. Some prior understanding of AWS Lambda as a platform will also be nice to have, but again, not crucial. I'll do my best to accommodate viewers of varying backgrounds and try not to assume too much prior knowledge. By the end of this talk, I'm hoping to leave you with a few fun takeaways. What? You can run a whole server, routes, middleware, and all on Lambda? Wow, I've never seen Swift running on a server. Neat. Waypoint is super approachable and easy to use. Without further ado, I'll jump straight into what using Waypoint with our new Lambda Function URL plugin looks like. I'll work from this repository that houses several different framework examples, starting with the Go example. This is a pretty simple HTTP server that runs on port 8080 and returns some HTML. First, I'll cd into my Go directory, run waypoint init, and then waypoint up. This will kick off a series of steps to build, deploy, and release our application. Behind the scenes, Waypoint is building an image of our app using Docker and handling all the imperative bits such as image tagging, image publishing, Lambda function provisioning, and setting up any IAM permissions. Waypoint up finished in 38 seconds, which is pretty fast in my opinion. And we can see a public URL for our app. And here's the HTML that our app returns. And another arbitrary route. And just to reinforce how easy and quick Waypoint is to use, I'll add some basic middleware and some API docs to our server and redeploy it. I'll uncomment these bits. This is our middleware, and this is our API docs. I'll save and run Waypoint up. So this middleware will enable us to toggle the theme of the HTML being served via query string params, and the docs are some random Swagger docs that will be available under the /docs route. So if we go to our deployment right now, the docs aren't yet visible since they don't exist for that deployment yet. So we'll just wait for our Waypoint process to finish. And this time it took 37 seconds, which again is super fast. And if we refresh, nice, our API docs are here. And then we can also check our query string param. And that works as well. You can already see how drastically Waypoint streamlines the deployment process for you. For a quick change of scenery, I'll move on to our Dino example. And to fill in any potential gaps that viewers may have, I'll give a high-level overview of our application code, our Docker file, and our waypoint.hcl file. This is our application code. With the specific language aside, chances are that everyone is familiar with this part. This is basically your home base as a developer. All of the examples I have today are using some popular request response framework like Express for Node, Flask for Python, Rocket for Rust, etc. An important call out here is that no special changes are necessary when writing your application code for a platform like Lambda and function URLs. There's feature parity between your development and production code, which is one of the tenets of 12-factor apps. Next up is our Docker file, and here's where the popular tool Docker comes into play. In case you're not familiar with Docker, if you've ever heard the term containers being thrown around, chances are folks are talking about Docker. If you are familiar, however, you'll appreciate the fact that Waypoint abstracts away all the repetitive tasks for you. So what is this Docker file? A Docker file is a series of instructions that specify how your application gets packaged into what is called a Docker image. An image is like a blueprint from which you or anyone can run multiple containers from. Running our application locally with Docker might look like this. Make build. This runs this Docker command, docker build -t dino oak latest. And running that container would look like this: docker run, and then a bunch of flags afterwards. And here is our app running locally with Docker. Zooming in just a little bit further, there's a special bit to note called a Lambda extension. This one is called AWS Lambda Web Adapter, and it's maintained by AWS Labs, but I have it conveniently hosted on my own container registry. This serves as a compatibility layer between Lambda and our friendly request response frameworks. Without it, our apps wouldn't be able to pass data back and forth between the Lambda platform and our framework code. And lastly is our waypoint.hcl file. Running application code and containerizing it are pretty standardized as of today, but deploying can vary significantly between teams as well as organizations. Conveniently for us, Waypoint streamlines all of this behind a simple interface. The gist of it all is that you simply provide a special waypoint.hcl file, which is a declarative file that specifies how Waypoint itself will build and deploy your application. And then you run Waypoint up, and it's really as simple as that. To give you a sense of the breadth of which you as a developer may use Waypoint, I'll go ahead and deploy a few more examples in other languages to our Lambda function URLs. Now I have a few terminal tabs open so that I can run several Waypoint commands in parallel. I'll go ahead and deploy the Dino, Rust, Next.js, and Swift apps. I'll cd into each of these directories and run waypoint init and waypoint up. I'm simply picking these 4 examples because Dino is the new kid on the block, Rust is pretty hot right now, Next.js just so we have an example that isn't another backend framework, and Swift because using a mobile app language to write a server that runs in a container that's executed in a serverless function makes absolutely no sense. I mean, so that iOS developers can see how powerful of a tool Waypoint can be for them. As you can see, Waypoint was able to deploy 4 apps in 38, 39, 45, and 48 seconds. Basically, several in under a minute. If this is not considered blazing fast, then I don't know what is. Now I'll just go quickly view our Lambda function URLs. And I'll just quickly open all of these in my browser. So this is our Dino example working. Our Rust example. Our neat looking Next.js example. And our Swift example. I'll gloss over the code to give a quick look at the various languages used. So Dino we already saw. We have a route handler at the base route that returns some HTML. And basically all of these examples return some HTML. This is the Rust example. Next.js, this is pretty standard for a Next app. And the Swift example. We have a route handler that returns HTML and one that says hello world. And that's pretty much it for Waypoint and deploying various apps to Lambda function URLs. Hopefully I showcased how simple Waypoint is to use and how quickly it can get an application fully built and deployed. If you have any questions or comments, don't hesitate to reach out and stay tuned for more to come in the Waypoint ecosystem. Thanks for watching.
That was an amazing overview. I personally love that it is so easy to get all 4 of them up in basically no time at all. And then the things I know about this, because that you don't know, that I really want to share with you are what make this even more interesting. Kevin is originally a Jazz School graduate who then stumbled into the coffee industry and eventually figured, you know what, I'll go into programming and software engineering. It's beautiful. Before we head on to the next sessions, we've got a couple of comments that I want to highlight. So, of course, the heat wave is here for everyone. And yes, the UK is getting one, and I think Daisy is solving this in the best possible way with much iced coffee. Guessing you and Kevin should talk, maybe exchange some recipes, figure out what the best third wave coffee is that you can throw in there. And then, of course, the thing that Kalen picked up on, and I did too, if I can find it in the chat again, we want that Zish theme. And I think Kevin is going to share that with us. We'll somehow get that up because that was beautiful to look at. The Apache color scheme in there, as Kevin told me, because I didn't recognize it, but it felt familiar, we all need that, right? Like you need that little rainbow. And then the last point I want to make, all of these sessions will be available on YouTube later on. So if you can't stay for the full 4.5 hours, you probably planned your day badly, but that's okay. We'll have them available later on YouTube. And I think with that, I'm going to be ready to hand it over to Philip, who's going to be talking about the opinionated future of managing Kubernetes with Terraform, and doing so with quite a nice touch.
So hello and welcome to my presentation titled Alternative Futures, Terraform and Kubernetes. This presentation will be about where we are today with Kubernetes management and Terraform, and I will present some alternative possible futures when it comes to how you would manage your Kubernetes resources with Terraform. So my name is Phil Blaine. I work as a DevOps engineer at Senate. Mostly my day job is managing Kubernetes clusters for customers. I work with tools such as Terraform, Kubernetes, Azure, AWS, and I do a lot of Go programming. I'm also a Microsoft Azure MVP and a Flux maintainer. If you want to get in touch with me, my contact details are below. Great, so for today's agenda, we'll quickly cover the basics of Kubernetes, or what you need to know for this presentation. We'll do the same for Flux, talk a bit about Terraform and Kubernetes, the current state of affairs, and I'll also then walk through some alternative solutions. So if you aren't aware about Kubernetes and what it does, all you need to know for this presentation is that Kubernetes is a platform that runs containers. It is configured through declarative resources, and this is kind of the more important detail that you need to understand. The way that you interact with Kubernetes is through its API server. These declarative resources are defined in a format called Kubernetes Resource Model, or KRM for short. The image to the right is an example of a resource that follows the KRM model. So you would have a API version always, a kind, which is the type of resource, metadata with name and labels, and then a specification or spec. The spec is what is different between the different kinds that are available, and they are different also depending on the API version of the kind. So as breaking changes are made to a specific kind, a new API version will be released for that kind. It also means that as Kubernetes versions are released, API versions may be deprecated and removed. Within Kubernetes, there are core API resources that are part of the Kubernetes project, but then there's also an option to define custom resource definitions. These are open API specs that define out-of-tree Kubernetes resources that other projects can define that also follow the KRM model. So Flux. Flux is a continuous delivery tool built specifically for Kubernetes. It is very typical or very similar to most other continuous delivery tools, with the exception that it follows or implements a concept called GitOps. So if you think about traditional continuous delivery solutions, you have a pipeline that pushes in configuration into the cluster. With Flux instead, you would run Flux inside of your Kubernetes cluster. It would reconcile from a source of truth. Initially, this was only Git repositories that were supported, but as time has gone on, this source of truth could be, for example, an S3 bucket, or maybe in the future an OCI registry. So the Flux daemon inside your cluster is reconciling with the source of truth. It will then apply the Kubernetes resources to the cluster. And any changes as they're pushed by the developer to the source of truth, they are then synchronized and pulled in and applied again. The Flux Terraform provider is a provider that the Flux project has built to support installation of Flux in a Kubernetes cluster. The process of installing Flux into a cluster is called bootstrapping. So what happens is that you have to add the Flux resources to the cluster, but then point it to a source of truth, for example, a Git repository, where its own definition is. So this bootstrap process allows you then to update the Flux installation through Flux itself. It was initially developed to fit a specific need that end users have, because they wanted to work with Terraform and Flux. So they wanted to create their Kubernetes clusters with Terraform and then bootstrap their cluster, or the cluster after it's created, with Flux, so that developers could then deploy applications. It has right about now 2 million downloads, and initial development started about 2 years ago. At that time, I wasn't too familiar with provider development and also how interactions or other Terraform providers interacted with Kubernetes. It has taught me a lot when it comes to provider development, and we're currently in a redesigning phase of the Terraform provider to look at easier methods or simplifying the interaction with the Terraform provider to make it easier for newcomers and beginners who are wanting to install Flux with Terraform, but don't want to do the amount of work that is required today with the current provider. So Terraform and Kubernetes. Kubernetes applications tend to not live in a vacuum. They tend to interact with other cloud services. So unless you're running, for example, all stateful applications inside of your cluster, they tend to want to talk to other databases or other types of cloud services like Service Bus or some other messaging solution. Kubernetes itself is also a very bare bones project, if you want to call it that, which means that to extend functionality that help developers deliver their applications, it requires additional applications that don't come from come in a vanilla Kubernetes cluster. So this requires you to add platform applications like Ingress Controller or external DNS or a governance solution or all of the above to a Kubernetes cluster after it's been created, but before the actual business logic applications can be deployed into the cluster. There are strong synergies here between creating cloud services for these platform applications running inside, getting outputs from output parameters after the resource is created, and then putting them into the resource definition that is applied to the cluster. So there's a clear life cycle there where there are a lot of people who enjoy or they are pushed to use Terraform to manage Kubernetes resources just because they have this typical life cycle of creating a cloud service, getting an output parameter, putting it into a Kubernetes resource, and then applying that resource to the cluster. But at the same time, this is a typical solution that cluster operators would use, but we still see that the majority of the people who develop applications internally tend to use other continuous delivery solutions like Flux, just because of the application lifecycle or the development lifecycle is very different compared to the platform applications that you might deploy into your cluster. So there are a bunch of different options out there today when it comes to managing Kubernetes resources with Terraform. There are a couple of providers that I use on a daily basis. There are probably a lot more out there than I know of myself. I will talk about the most popular ones that I feel are relevant. And then you also have the HashiCorp null provider or the null resource, which is technically a solution that you could use, but is nothing that I would recommend people to do, to basically shell out and have Terraform run a shell script for you. So we will not be focusing on that, but even though it's an option. The issue with the other providers that I am going to discuss is that they all have at least one downside. So this is, the downside could either be that they can't manage custom resource definitions, or they have issues when it comes to resource dependencies. So when I say resource dependencies, I mean that you might want to create one Kubernetes resource or deploy one application before the other. So a typical use case might be that you were deploying a governance tool like OpenGatekeeper or Kyverno into your cluster, which enforces some sorts of rules to other resources that you're creating. In those scenarios, you don't want, or you want to make sure that your governance tool is running and is healthy before anything else is applied. And then the third downside that might occur is API versions to your resource model might cause breaking changes where Terraform will force recreate the resource. So the Kubernetes provider built by HashiCorp is probably the most common provider that people use to interact with Kubernetes. It is also the simplest and the one that is used in a lot of examples. Initially, during its first versions, it only supported the core Kubernetes APIs. So you couldn't manage custom resources with this Terraform provider. And there are a lot of technical reasons why this is the case. It uses HCL instead of YAML. YAML is the common way to define Kubernetes resources, but in this case, it uses HCL. The big issue currently, as I see it, with the Kubernetes Terraform provider is that managing or updating API versions is still not something that is easily supported. So it is possible to do state migrations where you would move a resource from one API version to another without breaking the resource. So forcing to remove the resource and then add it again. But it still requires a certain amount of user involvement and understanding of the KRM model to do this in a safe and secure way. And it does now support arbitrary resources, custom resources, but it uses something called server-side apply in Kubernetes. I won't go into the details too much, but what this requires is that the Kubernetes cluster has to be created at initial or before the plan is run that is going to use server-side apply, which means that you can't create the cluster in the same state as you're applying the resources. This is a pretty contentious opinion regarding if you should have separate states when it comes to creating Kubernetes clusters and applying resources into your cluster, or if you should use, or if it's okay to do this in the same state. My personal opinion is that there should always be the option to do this in the same state. So that's probably also another issue with the current Kubernetes Terraform provider, where it requires you to have separate states. So two separate applies, one to create the cluster, and then another one to configure resources in the cluster if you're using the server-side apply functionality with this provider. This is how a resource defined with the Kubernetes provider would look. So in this case, we're creating a pod. There's a pod of V1 in this case. It has metadata, it has a spec. It's very similar to the initial example that we saw before in YAML, but in this case, it's in HCL. So another option out there is the Terraform Helm provider. Helm is a tool used to manage and package manifests, but also template the YAML files from a configuration file, basically. So it is an extra abstraction on top of pure YAML definitions. It's probably the simplest way if you want to do apply multiple different types of resources with Terraform without having to define everything yourself. It's easy to template, so you can pass Terraform variables or outputs as inputs to the Helm templating engine. It supports managing Kubernetes resources of any kind, so any custom resource would work with the Helm provider. The issue, and this is not a limitation of the Terraform provider itself, but a limitation of Helm, where Helm will only install custom resource definitions the first time, but if you upgrade the version of a Helm chart containing a custom resource definition, it will not upgrade these custom resource definitions. This adds a lot of limitation when it comes to managing or versioning some Terraform module, for example, where you wouldn't know if the latest CRD is actually applied or not. And it seems like the recommended way today is to manually apply the updates before you run Terraform. Another issue, which is also not the provider's fault, is that there are a lot of edge cases when it comes to state diffing and health checking. So making sure that a container is actually starting, making sure that the manifests that are generated by Helm are actually present in the cluster. From my own personal experience, I've seen a lot of issues when it comes to figuring out these types of weird edge cases, and they're more common than you'd expect. But this is how you would configure a Helm release in this case. So you have the name of the release, the chart name, and you have a remote source and a version of the chart, and you'd pass in some values for configuration. Yeah, and then you have the kubectl provider. So kubectl is the name of the CLI that you use to interact with the Kubernetes API. There is a Terraform provider that attempts to mimic the kubectl behavior. It's probably one of the best non-HashiCorp Kubernetes providers out there. It's good when you want to manage CRDs because it takes pure YAML as input. So it is very similar to interacting with Kubernetes in a more traditional vanilla way. One issue with this provider is that it does not support passing multi-doc or multi-part YAML in the same resource. So multi-doc YAML is when you have one YAML definition, then you have 3 dashes, and then you could define another YAML document in the same file. So this is not supported in this Terraform provider. Another issue with it is it does not support, it doesn't support API version updates in a non-destructive way. So it has the same issue that, or a similar issue that the Kubernetes Terraform provider has, where if you update the API version of your manifest, it will then see this new, even if it's the same resource, it will see the manifest as a new resource, and it will remove the resource and then recreate it. This is obviously something that you don't want to do, because instead you'd want the Terraform provider to apply the new version of the same kind immediately. And it also has a lot of issues when it comes to multi-part YAML and dependency complexity there. So what happens is that you'd have to split a multi-doc YAML file into multiple parts and then iterate through the resource if you want to apply it. And this creates large amounts of complexity. So this is how you would define a kubectl manifest if you want to do it in that way. So hopefully it's not time to just give up. All providers have their issues. And hopefully this is the part where I offer my own type of solution for these types of problems. But I think it's first important to find our own set of criteria when it comes to what a good solution would look like. So obviously we want to have the option of templating cloud service outputs into a Kubernetes resource. We want seamless API version upgrades. We want to be able to install and upgrade CRDs. We want to have custom Kubernetes resources. And we want to have a good solution to define dependencies between applications. So this is the point where you start to realize that maybe Terraform is not the best solution to manage complex Kubernetes resource or application deployments like platform applications, where you might have 10, 20 different applications that are running, that are doing their own small part just to be able to set up a functioning Kubernetes cluster. Flux, on the other hand, is a purpose-built tool that manages Kubernetes resources. And in its way, it fulfills all the criteria that we've already described. And in my case, for example, if you're already using Flux to manage internally developed applications and their lifecycle and how they're deployed, the question is then, well, why are we not using that to manage our platform applications? So it might be the compromise between only using Terraform to manage Kubernetes resources and only using Flux to manage Kubernetes resources. So the proposed solution or alternative solution is basically to ignore or to avoid using Terraform to directly interact with Kubernetes. So in this example here, in this alternative solution, you'd still use Terraform to create your cloud resources, but then you would template your Kubernetes resources, generate them, and then push them to the source of truth. And Flux would reconcile the source of truth. So you'd obviously first have to create the Kubernetes cluster with Terraform, then you'd have to bootstrap Flux into the Kubernetes cluster with Terraform. But when those two things are done, and currently then the only interaction with the Kubernetes API from Terraform side would be the bootstrapping process of Flux. But all other configuration changes are done from Terraform when it's interacting with the source. The reason, and one question that could be asked is, well, why have Terraform do this work against the source of truth instead of having, for example, a operations person do it manually? Well, the answer is really that Terraform is used more of as a Flux update automation tool. And the reason why you would want to do this is mostly because there are probably a lot of dependencies between, for example, the Kubernetes configuration, the version of Kubernetes that you're running, and the specific platform application that you're running. So you actually want to keep the versioning of the platform application manifests and the Kubernetes cluster creation tightly coupled with each other. You don't want to drift between these types of changes, basically. So what Terraform is doing is it's doing the same work that you might do if you were to use Flux today to manage your platform applications, basically. And this might actually be a better option if you want to do this manually if you have 3 or 4 clusters. But if you have 10, 20, 40, 50 clusters, or even more, going in and managing the manifests that are being deployed into the cluster with Flux manually isn't really an option anymore. So what you're doing is you're relying on Terraform to do manifest management instead of doing it yourself, basically. One issue with this is that it requires Terraform to make Git commits for you with a Terraform provider. Flux is adding support for OCI registries in the coming future, hopefully. And this will probably simplify things a lot. So instead of having to push manifests to a Git repository, you can push the manifests to a Docker registry and have it pull from there. And there are a lot of benefits with doing it this way. Another downside would be that you would introduce more points of failure with the complexity. So instead of having Terraform directly interact with your Kubernetes cluster, you're now relying on a separate tool and a separate reconcile loop, and there is interactions from Flux to your Git repository that could fail. So there are a lot more failure points in this solution. But at the same time, it removes all the dependency planning that Terraform has to do today with a bunch of Kubernetes resources. And if you end up managing a lot of Kubernetes resources with Terraform, you start to realize that Terraform Kubernetes clusters and Terraform state isn't really the best combination. And there are a lot of issues that you can find yourself in when it comes to like figuring out how to deal with apply order and things like that. And the last part is that the reason I think that this solution is going to be a lot better for the future is that you play into the strengths of Flux when it comes to, for example, dependency management and health checking. So it's then easy to do, for example, to make sure that your governance or policy engine that's running inside the cluster has to start, be healthy before other applications are being deployed into your cluster. And these are the types of things that are really, really difficult to do with Terraform today, just because of dependency ordering can break very easily when you work with Kubernetes manifests. So this would be an example of how you would do it. In this case, I'm using the GitHub Terraform provider as an example. So instead of just applying things, you'd have to bootstrap the cluster, and then you would commit your manifest straight into your GitHub repo. And what this example doesn't have, which you could have as an example, is templating in other parameters from creating some other cloud resource before you would commit this into Git. You could do multi-doc YAML in this case, so you could have one file with large amounts of Kubernetes manifests. So that's also an option. But if you've ever worked with Git or committing things with Terraform, you realize that there are issues because you end up with Git being a state and Terraform having its own state. And there are a bunch of different state updates that occur where you're not really changing anything in your Git repository, but Terraform has to update the Git history to be able to track the state. So you end up with a lot of dirty plans, basically. So this isn't really the option that I would go for. Instead, I think that as Flux adds OCI support, the options to skip Git altogether and just use registries is going to be one of the best options out there. So what's going to most likely happen is that Flux is going to implement a Flux push command, which allows you to, or what the Flux CLI is going to do is that it's going to package together manifests in the directory that you give, make it into an OCI binary, push it to a registry like ACR or ECR in a prepackaged way, which Flux can consume. What we could do is that we could expose the same type of functionality through the Flux Terraform provider. So instead of interacting with Git, we could have Terraform track changes to directories. And if, for example, the hello world directory changes in any sort of way, we could then push these or build a new OCI binary and push them to the registry. And I really think that this is kind of the future or the alternative future if you're kind of you don't want to go the way of dealing with Terraform managed Kubernetes resources. So as a conclusion, I just want to say that there are still a lot of challenges with Terraform and interacting with Kubernetes. Hopefully, I haven't been too negative about the other different providers that are out there. I think that they're great. I just think that they are not well suited for long-running clusters with large, complex manifest definitions. And I think that this as an alternative future, I don't think that it's going to be a common solution, but I think that it's important to discuss the different types of options that you have out there that avoid the different types of Terraform providers and all the small downsides that each provider has, where you're forced into using multiple providers to deploy the same application. Another challenge that we have today is that we still need to bootstrap Flux with Terraform. So Terraform still needs to have access to the API server to do the initial bootstrapping. So that's kind of an interesting subject area where if you could avoid that totally, you would kind of solve a lot of issues in just one swoop. And I still see that there are going to be people who look at the complexities of using Terraform to manage Kubernetes resources and will see this and go, I will only use Flux to manage my Kubernetes resources. And that's fine. And I see that a lot today, but it's mostly people who have few enough clusters where this is feasible. So the solution, that the alternative future solution that I'm proposing is basically looking at an option where where Terraform is an automated operator where you can manage versioning of your cloud resources and your Kubernetes manifest in the same location, basically. So hopefully you've learned something today. That was all. Thank you.
Whenever Philip talks, I do learn something, no matter if that's today or for the past 2 years whenever we've had a chance to interact. This is the content-filled kind of session that we hope to have a lot of. And I know in the chat, y'all asked for it. Kevin just shared the theme with us, well, earlier actually, but just want to make sure you actually get it because this is important. Your CLI should look beautiful, just like you do, because that will make you more susceptible to learning. In the meantime, I think we're ready for our next speaker, Derek, who's going to be talking about Nomad at the edge and some cool Nomad 1.3 features.
Hello, my name is Derek Strickland. I'm an engineer here at HashiCorp working on the Nomad project. Today we are going to have a discussion about running Nomad workloads at the edge, specifically configuring fault-tolerant, resumable workloads in edge deployments. So to sort of set the context, what are we talking about when we are talking about an edge deployment? Well, I'll refer you to this fantastic blog article written by my colleague Sarah, who will give you an in-depth overview of multiple use cases, but we're going to borrow a useful diagram from here. An edge deployment is essentially a deployment or a setup where your Nomad server cluster is running in one data center, and then your clients that are running workloads are somewhere else. It might be another availability zone in the same region. It might be across the world in another data center entirely. It might be a hybrid setup where you've got your servers running on-prem or in the cloud and your clients running vice versa. It could be a point of presence device or any other situation where there's a network segment between the Nomad servers and the client or clients that are running workloads. And Nomad's able to handle this type of a deployment pretty well due to our tolerance for high latency and network connections between the clients and the servers. The servers themselves communicate over the SURF protocol, which requires a low latency connection between the servers, but with the clients, there's a much higher tolerance for a slow network connection. Historically, Nomad has dealt with a complete disconnect from a client, though, in a manner that is maybe not best suited for running an edge workload where you might expect, periodic interruptions of network connectivity between the control plane and the workers, or maybe you expect to have occasional consistency or occasional connectivity by design. For instance, a device that's on, a client that's running on a vehicle or something like that. In those sort of situations, connectivity with the control plane might be expected to be broken for long periods of time. What would happen historically is if a client lost connectivity for longer than its heartbeat grace period, the workloads on that client would be marked lost and stopped, and then when the client would reconnect, those tasks would be shut down. They might continue to run on the client for the entire duration of the disconnect, but then they would shut down as soon as the client reconnected, sort of as a matter of policy. We previously released a configuration option that you could set your jobs that were running on clients, where you could tell them, hey, if you disconnect, go ahead and stop yourself if you remain disconnected for a certain amount of time, and run whatever shutdown configuration you have configured. And that setting was called stop after client disconnect, and you could basically tell the workload to shut down. What we're exposing now is a new configuration called max client disconnect, which is sort of the inverse lever that you can pull. And what this tells a job to do is, hey, or more accurately, tells the server to do is, hey, if this client running this task configured with this value reconnects within the duration you specify, just go ahead and reconnect and resume the workload. Don't shut it down. So we're going to take a little tour of some existing, the existing behavior and the new behavior here over the course of the next 30 minutes or so. So let's start with taking a look at some job configuration. So this is a job. All the jobs in this demo are going to be named Edge. You'll see why in a minute. And in this particular job, we've got a simple task, and we have not configured max client disconnect or stop after disconnect on this job. More accurately, on the task group within the job. And so if we were to run this job, we're going to come over here. We're going to start a little watch on the cluster. And if we were to run this job, which has no max client disconnect configured, once it's deployed, we will simulate a network outage between the client node and the server node. So over here on the right, I've got a console open and I'm SSH'd into my client. And I'm just going to insert, we can see the deployment's complete down here where I issued the run command. We can look up here in the status, the watch I've got going on the status, and we can see that everything's healthy, everything is running. So over in the client on the right-hand side, I'm going to simulate a network outage by inserting an IP tables rule that blocks traffic between the client and the server. And I'm going to go ahead and hit enter on that. And what happens if you're not familiar with Nomad architecture, there's a heartbeat mechanism that runs on a staggered 30-second interval, where the agents will, check in with the servers and say, hey, we're here, and everything's good to go. And if that check-in process doesn't happen, historically, what would happen is the client, or the node rather, the client node would be marked as lost, and or down rather, and the allocations that were on it would get marked with stop lost. And if we look over here in the output of our watch, we can see that several of our allocations have transitioned to stop lost, desired status of stop, with the actual client status of lost, and they're all running on the same node, which just happens to be the node that I disconnected. And they got replaced. Some new allocations were spun up to make sure that the cluster stayed in the desired state. And then if we were to restore connectivity by removing that IP tables rule, nothing really is going to happen to those allocations. There's no way to recover them. They got shut down as previous behavior dictated. So we're going to go ahead and purge that job. And then we're going to take a look at our next job spec. And we're going to look at a basic deployment for a basic job spec that has this max client disconnect setting configured. And what I've configured here is a maximum of 2 minutes. If the client disconnects and reconnects within a 2-minute interval, then the jobs will reconnect and resume. While they're disconnected, the cluster, the servers will go ahead and deploy replacement allocations, just to make sure that the cluster has the capacity that's expected. Now, if you don't want that behavior, you can configure attributes, constraints rather, that will, ensure that the job can't run, anywhere other than a certain node, or you could configure, reschedule configuration and control it through those levers. But in this case, I want to illustrate for you, the full range of operations. So I've got this basic job, and I'm going to run it. And it's called spread, or I called the task, or it's actually called edge, but it ensures that we're going to spread our job equally across hosts within the data center. So we should end up with 3 on each of my clients that I have running. So I'm going to run that edge job, and it gets deployed. And as the deployment is running, everything looks good. We've got 6 that we desired 6 to be placed. 6 have been placed. Now we're just waiting for everything to check in with the control plane and let it know that it's healthy. And now we see that they are indeed healthy. Now, in this case, I'm going to once again simulate a connectivity loss, and that 30-second plus or minus timer is going to looping and looking for the client to check in. And once the client fails to check in, what's going to happen is the allocations running on that client are going to get marked as with this client status of unknown, and we can see that that happened right here. Okay. And then the nodes are now going to have a status of disconnected, the one that's just because it has a workload on it that can tolerate a reconnect. I'm going to go ahead and reconnect so that I don't hit my 2-minute barrier, and we're going to watch what happens. So apparently we were in a really close to the threshold of that loop running, and my client checked back in, and the workloads that were on it went back to the running state. Okay, nothing happened. If we were to do a Nomad, they weren't shut down. If we do a Nomad status on that alloc ID, we can look real quick, and we will see that in the events on the task, we can see that a reconnect event happened, and the task was not shut down. And then the 3 replacements that had the newer timestamp, the newer created timestamp, those were actually shut down. So the cluster's back at the capacity that we desire, and the workload ran without any interruption. So that's good. Let's go ahead and purge that job and talk about our next use case that we're going to illustrate. So what happens if a job does expire while you're disconnected, where you reach that threshold before the client can reconnect? So I've got another job. It's basically the same job, but I've configured a much shorter 10-second duration. It can only tolerate being disconnected for 10 seconds. This may not be very realistic for your a real life workload, or it might be just depending on your use case. But in this situation, it's just optimized to allow me to illustrate behavior more quickly in the demo. So I'm going to run expired this job, and we'll see that it gets placed, and sooner or later, the deployment will complete, the tasks will be healthy, and as soon as the deployment completes, I'm going to go ahead and I'm going to trigger this IP tables rule again, and that is going to simulate again a disconnect, a loss of line of sight. That might be a router misconfiguration, a firewall misconfiguration, physical break in cable, whatever. The client and the server have lost the ability to see each other. The line of sight is gone, and connectivity has been disrupted. And like I said, it takes about a 30-second, runs on a 30-second plus or minus loop. And so sometimes, just depending on when you hit the button, In the demo, it takes a little longer or a little less longer in some cases to see the transition of status happen. But in this case, we should get there pretty soon. And there we go. Once again, this client that I'm manipulating, C40, it now has 3 tasks on it that are running an unknown, and we can see that 3 replacement allocations were placed. And so the now check that out. What just happened? These 3 on C40, they just transitioned to lost. Well, why was that? Well, because we said, hey, you can only tolerate a 10-second disconnect, and once that happens, please go ahead and stop those allocations, or at least at the server level, mark them as desired status of stopped and client status of lost. And then once it reconnects, what we'll see is here in a couple of seconds, this client status of lost is going to become complete. And what that tells you is the tasks will gracefully shut down once they reconnect, and they realize that the control plane no longer wants them to be running. And there we go. That transition just happened, so everything shut down gracefully, and we're good to go. So we will go ahead and purge that job. Now we're going to come over to our next use case. And in this case, we're going to configure a job that fails. Why are we going to do that? Well, if you have a failed job on a client node that disconnects, and it fails while the disconnect happens, and then reconnects, you don't want to shut down these jobs, the replacement allocations that were running successfully in another client node. You want to just be able to detect that, hey, this didn't work right while it was offline, so I'm going to keep those replacement allocations and then just try to basically acknowledge that the newly reconnected allocations are not running. So we're going to run that real quick, and we'll let that kind of play its little 30-second timer loop game after the deployment completes successfully. And there we go, the deployment has completed. So once again, we'll break the connection and wait for those to transition into a unknown state. And if we go back to the job spec, we'll look and we'll see just real quick, just to show you, they're gonna fail after about 30 seconds. That's what I've got a script injected in the job to configure to work that way. So here we go. Here are our 3 unknown allocations. Again, the client will show up as disconnected in the CLI output as well as the UI, because it knows that the cluster knows that it has workloads running on it that might be resumable. And so rather than calling that client down, we now call it disconnected. And so we'll go ahead and restore connection, and those should have failed. 30 seconds certainly should have expired, and it did, and we were really close to that barrier, that timer loop barrier. And you can see that those 3 are marked as failed, just like we would expect them to. So we'll just go ahead and purge those. And we'll come back to what is probably going to be our last use case that we'll be able to show right now. Maybe we'll have time. And what happens if I increment the job version, if I mutate the job somehow while one of the clients is disconnected? If I've changed the job definition, I would not want the reconnecting client's allocations to resume. I'd want to keep the updated allocations on different clients. And so in this case, if we look at job v1 versus job v2, what's changed is I've changed the image. I'm moving from Redis 3.2 on v1 to Redis 5.0 on v2. So we'll come over here and we'll run job v1. And let that deploy. And once that deployment is complete, we'll go through this same little dance again of simulating a network drop. Deployment's complete, so we will execute that network drop. And then once that happens, we'll go ahead and deploy an updated version of the job. We just need to make sure that these transition to unknown first and the replacement allocations get placed. Bear with me as we wait for that timer to fire. And the replacement allocations to get spun up. And there it goes. So we've got 3 unknown, 3 pending. Those 3 pending are now running. So that's great. So let's go ahead and apply version 2 of that job, which is a destructive update because it can't be made in place. It's not just metadata. And now what we'll see is that the new pending jobs for version 1 are getting placed. The version 0 allocations are getting marked for stop, and that'll take just a bit to complete. And once we get there, once that deployment is done, we will reconnect. And once the timer finishes firing, we should see that the reconnected allocations get stopped and shut down because they no longer have the most current job version. So we got 3 placed, 2 healthy, just sort of waiting, running all this locally here in a Vagrant environment with low memory, et cetera, just to kind of help with resource consumption. So it takes just a bit longer than it would on a production cluster, as I'm sure you can imagine. Got 4 out there. You can see them here, job version 111. The others are shutting down. And once we get to a point where all 6 are healthy and the deployment is complete, we'll go ahead and reconnect and watch what happens. We're almost there. Oh, here we go, 6 placed, 1 more to go to health check in, and the deployment should complete. And we are good, we're good to go, great. So now we've got 6 versions of 6 instances or allocations of job version 1 running. The others have been stopped, but we still got a few down here in this unknown status because the client is still disconnected and its timeout hasn't expired. So we're going to go ahead and reconnect it. And then what we should see happen is those unknowns will transition into a stop complete status as soon as they're able to reestablish connectivity. And there we go. They stopped and they're completed, and the cluster has the desired number of allocations running with the right job version. So we'll go ahead and purge that, and it looks like we are going to have time for one last use case here. We're going to, over in my IDE, I've got a canary deployment set up. Canaries are a way of doing updates where we roll out a little bit at a time, if you're not familiar with it, Google it, take a look at it on the internet. I'm gonna move quickly here for the sake of staying within our time constraints, but we're going to run our canary. We're going to run the first version and get that deployment out. So that's running, and we'll queue up our network disconnect script over there. And once these are healthy, which they are now, we'll go ahead and we'll do our canary update. And what we're going to simulate here is what happens if a canary rollout gets interrupted by a client disconnect. And so I'm going to wait till we've got 3 canaries, let's say 3 placed and 1 healthy, and so that we are, kind of really in flight or I'm sorry, too healthy. And then we're really in flight. Things are kind of in an inconsistent state, and we don't know exactly, maybe some of the allocations are pending, maybe they're healthy, et cetera. So I'm going to wait for that to happen for us to get to that stage of the rollout before I simulate the disconnect, just so we can get a really sort of chaotic state in place where a network disruption might really, put the feature through its paces. So we're just going to wait for that to run. All right. Bear with me again, running on a little bit of a nerfed environment to make sure that all the other resources necessary for recording, et cetera, have what they need. We've got one out there running, and that should finish. Should update here shortly. Well, unfortunately, I'm out of time. It looks like. So I am going to have to let you all, imagine how this is going to finish. But basically, what's going to happen with the canary deployment, it'll get to a certain point. We would disrupt the internet connection or the network connectivity between the client and server, just like we did previously. What'll happen is, whatever's been deployed, the canary deployments get placed, and the network connectivity will be lost. It'll replace those canaries, and then what'll happen is it basically, if an allocation was part of a canary deployment, it will just get shut down rather than being brought back into the cluster. We just sort of assume that, hey, if we were in the middle of a canary deployment, that deployment wasn't really complete. Go ahead and prefer the replacement allocations over the canaries, and keep trucking with those. So again, my name is Derek Strickland. I am so glad you joined us today. I hope that you found this useful, and that you will be running all your edge deployments on Nomad.
How else would you run your edge deployments? If you're talking traditional edge devices, you're usually talking very industrialized components, stuff that is hard to reorder, and usually, even in 2022, does not come high powered. So yeah, any bit of extra juice that you can get out of that hardware and not clog up with resource hungry processes, you're going to need that. And Derek told me that the demo did indeed work at the end. So you'll have to take it from me. With that, I know our schedule initially said that we would have a break here, but since our flow is going so nicely, we're just going to switch over to Isaac Lauer, who's going to talk about the missing abstraction between dev and deployments.
Hello, my name is Isaac Lauer. I'm a senior software engineer on the Waypoint team, and I'm going to be talking to you today about Waypoint, specifically its capacity to serve as the missing abstraction between devs and deployments. So first, let's introduce our actors. We're talking about deployments. Deploying is the act of taking an app that's been produced by an app developer and getting it to run on some infrastructure, typically managed by infra devs. So you've got like a Flask app on one side, you've got a Kubernetes cluster on the other side, and deploying is getting those two parts to interact. Let's examine the problems with deploying from these two different perspectives, the app dev perspective and the infra dev perspective. So first, let's introduce a fictional app dev. We have here Danielle. She's a senior software engineer. She's relatively new to this company, but this is not her first rodeo. She knows her way around a Flask app. And in fact, she's just finished one. It's a stateless little 12-factor app, and it's ready to go. She is ready to solve an actual company problem with it. It is time to deploy. But before we deploy, we've got to figure out what deploying means for this company. So Danielle goes, talks to coworkers, looks at other similar repos, reads documentation, and figures out that at this company, deploying means building a Docker container, pushing it up to and running it on a GKE Kubernetes cluster in GCP, releasing it behind a GCP load balancer, and orchestrating all of that through Circle CI. Great. One problem. Danielle doesn't know these tools. At Danielle's previous company, she was building DEBs, baking them into AMIs, deploying them onto EC2, releasing behind ALBs, and orchestrating it all through Jenkins. So Danielle knows the steps that she needs to do. She knows what the workflow looks like, but she doesn't know any of the tools. So step 2, learn the tools. Let's start by installing everything. Install Docker Desktop, install kubectl and configure that. Install gcloud, configure that. Read a bunch of docs. All these public tools have they have a bunch of docs. It's a very deep rabbit hole. She's also going to look around for any private internal docs that the infra team may have published on how to pull this off. Inevitably, that's probably not going to cut it. She's probably going to have to ask for help from other app teams, maybe even engage infra directly for some sticky problems. But Danielle is a persistent, tenacious engineer, and given enough trial and error and more error, she is going to figure out what letters she needs to type into her terminal to get the app deployed onto some actual infrastructure. So we've pulled that off. Are we done? Not done. This is in some parts where the real hard part begins. I'm sure some of you are familiar with this chain of commits. Now we need to figure out how to take those letters that we type locally and embed them in like a bash script inside a YAML file that is your typical CI pipeline that will get CI to run all of those steps to deploy on, say, a push to your main branch or a PR merge or something. This is the automation part of deploying, and it comes with its own pain and headaches. So Danielle's finished all that now. She's got the pipeline working, she's made the commits, and she thinks, wow, that is actually a pretty big body of secret knowledge that I just obtained to figure out how to do this. I had better write this down so I'm not the sole holder of it. So she writes a big doc that the rest of her team, she assumes will be able to use to operate the app in production. And now, at last, she figures she's done with her journey. She can go back to writing apps. But I have news for Danielle. Danielle, you're a DevOps engineer now. This isn't necessarily a bad thing. This is how a lot of us got our start. Those of us who work in the DevOps space, we were the one, bold, plucky engineer who was willing to figure this out for the first time. But for Danielle, who really wants to get back to writing apps, this isn't ideal. The first time the app breaks in production, she's probably going to be the first one who's tapped to go in and figure out how to do a rollback. The first time the pipeline needs to be patched, she's probably going to be the one to do it. She can do all she can with docs and knowledge transfer, but in my experience, that kind of knowledge transfer is usually not 100% successful. It seems like there are usually 1 or 2 people on the team who are the YAML wizards, who are the DevOps people, who know how to wrangle the pipelines. So, what were the problems from Danielle's perspective? She started being familiar with all the concepts on how to deploy an app, but she still had to do a bunch of learning. She spent a great deal of time not building her app, doing the thing that she's ostensibly paid to do and measured on doing well. She's going to have to continue spending a bunch of time percolating that knowledge throughout the rest of her team, and she is not looking forward to bootstrapping the next microservice. She knows what she's in for now to pull it off, and she knows it's not trivial. So, switching perspectives. Let's now look at this from an infrastructure engineer's perspective. I introduced Brennan, a cloud platform engineer. Brennan is an old hat. She's worked here for a number of years. She helped stand up all the initial infrastructure, knows it front to back. She manages the GKE clusters that the app teams all deploy into. She makes sure they're up to date, makes sure they're all, the workers are always reporting as ready. She also manages and maintains the logging infrastructure, includes a handful of Elasticsearch clusters. She does a lot of this through Terraform, and her fun side project is she's building a little security scanner tool that will prevent anyone from deploying a known vulnerability to production. So, what are Brennan's problems? Problem number 1, teaching. That app developer from the last phase, Danielle, odds are she was not entirely successful at being self-sufficient. She probably asked for help many times along the way. Brennan would like to just get back to building her sweet container scanning tool, but she keeps getting dragged into Slack conversations to help debug failed deployment pipelines and help onboard new teams onto the platform that she maintains. Problem number 2 is infrastructure changes. Let's say it's time to change tools. Maybe we have to upgrade a Kubernetes cluster, which could mean changing the cluster URL. Maybe we're going to switch platforms from, say, GCP to AWS. Maybe AWS just gave us a sweetheart deal with a bunch of free ECS credits that the company would like to utilize as free compute. Maybe we want to introduce some new stage in the middle of the pipeline, like that security scanner tool. This is going to be a hard problem for a couple of reasons. The first hard part is that there is no central place where all of your infrastructure is declared from the app developer's perspective. All of those app developers wrote their own little bespoke pipelines. And for you to change all of them, you're going to have to go either reason about each one independently and make a PR and hope they merge it, or ask the app developers to migrate themselves. And odds are they might not take that well. The second problem is even more insidious. It might seem like the only place that's tightly coupled to the infrastructure is the automation, the CI pipelines, but actually, the app devs have tightly coupled themselves to the infrastructure. We asked them to get up to speed with all the tools, and they did. They installed kubectl. They learned how to use it, how to type, how to blaze a path through that tool to figure out what they need to do to get their app up. And asking them to switch tools is going to be met with some resistance, because from their perspective, they're going to just have to learn how to do the same thing in a different way. So there's pain on both sides. Maybe let's examine what each side actually needs to think about how we can structure a solution. What does an app developer need? Developers need to build some kind of artifact, Docker container, VM image, what have you. They need to deploy it somewhere into some cloud. They need to get it running somewhere on real infrastructure. After that, they're probably going to want to inspect it. They're going to want to curl their deployment, make sure that it's responding as they expect. They're going to want to get its logs. They might want to exec into it from time to time to, debug a thorny issue. Eventually, when they're satisfied with it, they're going to want to release that deployment onto the internet or the intranet for real consumption. And for all of these things, they really don't have strong opinions on how. As long as the workflows that are provided are relatively straightforward and are fast and snappy, they're going to be happy with it because they really just want to get back to writing their apps. Now, what do infra devs need? Infra devs are tasked in most organizations with selecting and operating the best, most secure, fastest, most efficient, what have you, infrastructure for the company at any given time. And infrastructure these days is a very fast-moving place. So those tools are going to change. And when the tools change, the infra devs need to have a way to switch them to a more appropriate tool or a better tool or a cheaper tool without burning all their political capital running around convincing all of the app developers to migrate to. And they also want to help app developers, the infra devs, spend their time managing their applications and not dealing with the infrastructure. The infra devs they want to help use their knowledge to prevent app devs from figuring all this out themselves. There's a reason that we generally don't give app developers just the keys to a new AWS account and say, go for it, build it from scratch. We want to save them some time, and we also want to encode some best practices to make sure these things are done the right way. So this brings us to the missing abstraction layer. It seems like an abstraction layer is what we need. We need something that sits between the developers and the actual infrastructure. Something that presents the developers with an interface that allows them to do the things that they care about without exposing too much detail, that lets them build, deploy, and release. On the other side, we need this abstraction layer to expose the full complexity of the infrastructure to the infra devs and allow infra devs to unplug and plug infrastructure into it to give developers a unified experience no matter what infrastructure you're on. So now that we've defined this problem, that we need some kind of an abstraction layer here, I introduce HashiCorp Waypoint. So what is Waypoint? Waypoint is an open source project at HashiCorp with an aim to address this problem. And let's talk about it from these two perspectives. Let's start with the app dev perspective. Waypoint for app devs provides a single interface that allows developers to perform the actions that they care about. It has commands to build, deploy, and release apps. It also exposes commands like logs, where developers can get a live view of their application logs, and exec to get a shell session into their running instances. It also, it presents the developers with the information that they care about. So like when they deploy, it gives them a URL that they can use to reach that deployment. It also gives them a high-level summary of the status of the resources that are actually being created in the infrastructure, but it doesn't rub their noses in like all of the nitty-gritty details of exactly what's going on down there. Waypoint has a CLI that exposes the build, deploy, release commands. It also has a unified up command, so developers can run Waypoint up, and it'll take any code changes that they have all the way out to production and release. The CLI can also take advantage of the fact that it's often being run from the directory that the code lives in. So you can do things like deploy an exploratory change without having to first push your code to main. Waypoint also has a UI, which lets you perform many of the same actions as the CLI, but also gives you some visibility into like who deployed what when and what the status of all your deployments are at a quick glance. All right, now let's switch gears. Let's talk about infradevs. What do we have for them? Underneath the shiny build, deploy, release workflow, Waypoint lets infradevs configure what each of these actions means in the context of their organization. And because every organization has different needs and runs a different suite of technologies, the infrastructure layer in Waypoint is very pluggable. It works great with all the HashiCorp tools, the Hashi stack of Nomad, Console Vault, etc. But it also works with a wide variety of other infrastructure providers and platforms like Kubernetes and AWS Lambda and Google Cloud Run. So how do infradevs configure Waypoint? The first layer is through the waypoint.hcl file. You can see that the first line of this file is build. Everything inside that build stanza is the instructions on how to build the app. In this example, we're building with Docker and we're pushing to a Docker registry. I'm sorry, we're building with Pack and we're pushing to a Docker registry. Get this out of the way. Every app in Waypoint gets its own Waypoint HCL file, which can give you the flexibility to have different infrastructure behavior per app, if that's what you need. Where does this file live? It depends on the org. For some orgs, they prefer this file to be primarily owned by the app developers. And for them, they can commit this file directly to the app repo and Waypoint will read it from there. For orgs that want a harder abstraction layer between the app devs and the infrastructure, this file, the Waypoint HCL file, can be stored on the Waypoint server in the domain of the infradevs. Now let's talk about the next layer, plugins. For orgs that need a lot of flexibility, more than can be provided through the configuration in Waypoint HCL, Waypoint has a plugin system that allows you to write Go plugins that can give you exactly the behavior that you want. The plugin system in Waypoint is very deeply ingrained. Every interaction, in fact, with the infrastructure in Waypoint is handled and mediated through a plugin. Waypoint ships with over 30 plugins built in, but if you're a platform engineering group and you need a very specific deployment workflow, or if you need to target some custom infrastructure that Waypoint doesn't ship with support with, you can write a Waypoint plugin that defines exactly what deploy means for your organization. And that's a brief introduction to Waypoint. Let's pivot now to a demo and show some of this in practice. All right, time for a demo. I'm going to show you how you can use Waypoint in practice to be that abstraction layer between developers and deployments. Specifically, we're going to take an app, we're going to use Waypoint to deploy it onto one platform, in this case, AWS ECS, and then we're going to change the infrastructure out from underneath. We're going to migrate over to Kubernetes without the developer having to change their workflow or really even be aware of the change at all. So I've got here two different hats. I've got an app developer hat and an infradev hat that I'm going to be switching between to show which persona I'm embodying at any given moment. I also have two terminals here. I've got an app dev terminal up here, infradev down here. And with that, let's dive right in. So I am an app developer and I have produced an application. Let's go look at it. It is your basic Node.js web server. Not a whole lot going on with it. The interesting thing to note here is that there's nothing in this repo that is tied to any infrastructure. There's no Docker file, there's no Kubernetes manifest, there's no pipeline YAML, nothing. The only thing in here is files that I, as an app developer, would know that I need to include because they're the files that are necessary to make the app work. to run the app locally. I've tested it. It works great, and I'm ready to put it out on some real infrastructure. Platform engineer can have some help. Infradev hat on. Yes, we're going to deploy this thing. So to do that, we're going to use Waypoint. I have done a little bit of pre-work here. I've installed a Waypoint server onto an ECS cluster. I've set up a remote runner and a runner profile. We have docs on how to do that. I'm not going to dive into it now. And let's get right to it. Let's create a new project. This is going to be called HashiTalk. I'm going to connect it to a Git repository. This is where the code lives. I need to tell Waypoint so it can build and deploy the code. No authentication here. It's a public repo, but you could certainly do this with a private repo. And importantly, I'm going to set this to have Waypoint config live in the Waypoint server, not in the app repo. And I have also pre-made just a little bit of Waypoint config. So this is a pretty basic one. We're going to build using build packs. We're going to use a Docker registry to push the image that we create to the Docker image, and then we're going to deploy onto AWS ECS. This is just some basic config. I'm going to do it in USS1 with this much memory. This is a deep rabbit hole. There's a ton of config you can use for ECS to make this work exactly the way you need to for your org. Paste this in here, and we're good to go. And that is pretty much all we need from the app developer's perspective. We can invite from the infradev perspective, we can invite the app dev to Waypoint, cut a Waypoint user for them. We're going to assume that's already done. They've already installed the CLI. Switching contexts. All right. I am the app dev. I am going to, and I'm ready to deploy. I'm going to run Waypoint up dash project equals HashiTalk. And actually, I'm going to wait until this initialization is done. I'll warn you. There we go. The weather in US West 1 is not great today. I think it's taken ECS a while to spawn tasks, so we might have to fast forward through some bits. But now we're ready. Here we go. Waypoint up, and here we go. It is kicking off a job. What are we waiting for here? What we are waiting for is for Waypoint to launch a separate ECS task that is going to perform the build for us, the build and the deploy and the release. Again, this is the all-in-one up command. It's going to take the thing all the way out to the internet. There are a lot of benefits to doing it this way instead of doing the build on my laptop. One is I don't have to have anything installed or configured at all. I don't have any reference to, I don't have the AWS CLI installed here. I don't even have AWS credentials, period. This is all happening through, AWS role and policy auth from the instance that is executing this in ECS. It's a consistent environment, so you can bring a new app developer in and it'll just work for them. I can throw more resources at it if I want to by making bigger ECS tasks to make the build faster. It's more secure. This is a nice way to do it. And it's building. It's using Kaneko because it's in a container, and it will finish in just a minute here. I will also warn you, Node.js pack builds are not the fastest thing in the world, so we might have to just speed through this. While we're waiting, though, let's pop over here and look at what this looks like in the UI. We have a build that's running in the UI. We can inspect it. You can see the build logs here in the UI and see what's happening. Anybody on your team can view this to figure out what's going on. And let's now just speed ahead until this is complete. All right, wow, that was fast. We're already deploying, and we are now releasing, and we're done. So now I, the app dev, I have a release URL that I can use to hit the running instance. I've got a deployment URL. This says it's complete. It says it's deployed and released over here. Let's pop up one level and see what that looks like. Here's my deployment. It says it's in a degraded state right now because it hasn't passed its first health check yet. That'll happen in just a second. And let's give this a second actually to finish coming up all the way. I'm gonna rerun the health check, and we'll check back in when it's actually up. And we're up. It's now showing me that we have some resources that it created inside ECS. It shows me the task, the cluster, and the service. It's showing me the logs here. I can also get the logs in the CLI over here. If I run Waypoint logs, it'll give me the live logs. The app dev, am now confident this is working as I expected. I can also use this deployment URL to inspect this deployment in particular. Hooray, my app is up. It's on the internet. Life is good. Time to switch hats. I am now an infra dev again, and I have decided, or it's been handed down or whatever, we are moving. We're switching infrastructure. We're moving to Kubernetes. Maybe I just learned about Kubernetes. Maybe I'm tired of slow tasks in US West 1. But for whatever reason, that's what we're doing. And I'm going to have to do two things to pull this off. So the first thing I'm going to do is reconfigure this app to deploy to Kubernetes instead of ECS. And to do that, all I'm going to have to do is change this deploy stanza. I've got this ready. I have this deploy stanza down here. The one interesting thing I'm doing here is telling it to use this demo team namespace, just to show there's nothing up my sleeves. Ugh. Here are I'm connected to the Kubernetes cluster I'm going to use. Here's my namespace. There's nothing in it yet. And I would like to deploy in here now instead of into an ECS cluster. The other thing I'm going to have to do, that I'm going to want to do, is change it so that the operations themselves, the Waypoint operations, build, deploy, release, that those execute on Kubernetes jobs instead of ECS tasks. The benefit of doing it here in Kubernetes is that I can then use Kubernetes service account auth instead of having to like take a kube config and give that over to my ECS runner. It's more secure. It'll also be faster. And to do that, I'm going to use Waypoint runner profiles. So I have two runner profiles here that I've already made, the ECS one and the Kubernetes one, that are targeting their respective runners. And the ECS one is the default. I'm going to switch the Kubernetes one to be the default. So ECS, default false. Kubernetes, default true. This is simulating like an org-wide switch to Kubernetes. You could also do this piecemeal. You could target Kubernetes in this specific for this specific application if you wanted to. And that's it. That is all I have to do as the infra dev. Let's go put our app dev hat back on and see what that looks like. I'm the app dev. I've made a change to the app. I've pushed it. I would like to redeploy. I'm just going to run Waypoint up again. Let's see what happens. So it looks like it's happening on Kubernetes now. Not that I need to know. We're building. Let's just real quick, let's put the infra dev hat on and see what this looks like in the infrastructure. If I get pods, I've installed the runner into the default namespace. So here in the default namespace, you can see here's this task running. This is the task that's actually performing this build that's going on right now. Let's pop back over to the UI, look at the build, currently building, and then let's put the app dev hat back on and just wait until this is done. Should be just a minute. There we go. Build is complete. We're releasing, and we're up. And here we go. I've got a deployment URL. I've got another release URL. I can inspect this again, make sure it's working. Let's show that logs and execs still work the way I'd expect. Logs still look good. And if I was a really nosy app dev and really wanted to know what's going on, let's say I'm going to use the exec functionality to get in here. Let's say I'm like, I want to poke around the container, make sure it's working. You can disable this for you if you want for your org. But in here, I can run the hostname command. And that is not an EC2 style hostname. That's a Kubernetes hostname. We did it. We deployed the app on Kubernetes, and I, the app dev, didn't have to change my workflows or knowledge at all. And that's the demo. All right. And that is the talk. Thank you for listening. If you'd like to learn more about Waypoint, you can go to waypointproject.io. If you'd like to poke around through the code, or you want to think about writing a plugin, or really want to dig in, github.com/HashiCorp Waypoint. It's open source. My name again is Isaac Lauer, and it was great speaking with you.
HashiTalks build is very much about figuring out content that pushes you forward and breaks down silos. And what better way than to showcase the two most common silos that we have? So Jennifer, for your question, is this a demo that we can try ourselves? Absolutely. It's released on the Waypoint repository. You can grab it from there. Maybe even try it in the next 15 minutes because we are heading into our first break of the day. So with that, take 15 minutes, get yourself something to drink, maybe figure out what Kevin's favorite third wave coffee is, and we'll see you back here in 15 minutes. Welcome back. Hopefully you had a nice and relaxing break, or just tried out the Waypoint demo from Isaac. That was very, very cool. We're ready for part 2 of HashiTalks build for today's sessions, and I'm very excited to introduce you to Leon Nunes, who's a first-time speaker and a DevOps engineer who loves to tinker with Linux systems. I mean, who doesn't? That's the fun part, really. I'm excited to learn more about reducing blast radius with Terraform. And with that, I would say, let's just switch over.
Good morning, good afternoon, good evening to all who are attending this session. This session is on reducing the blast radius in Terraform by splitting the code into various folders and using remote data sources to pull data from different folders. So basically, this helped me, the split monolithic code into smaller folders, but this may not work for everyone. So this is just one method that can be used. There are also other methods where you can use data sources or modules to split the code into logical parts that can help you write simpler code and easier code to understand. So this is just one of the methods that I found out or came across, and it helped me. So this is what this talk is about. I apologize for any audio issues in the video. I don't have a proper mic, so there is a lot of distortion. So in case that is there, I have also written an article about this. So you can probably read that, and if there are any questions, I'd be happy to answer. Yeah, about me, my name is Leon. I am a DevOps engineer at a startup called Signians. We are an AWS consulting startup. My pronouns are he, him, and my Twitter handle is mediocre DevOps on Twitter. I mostly work with AWS consulting and cost optimizations along with Terraform. Yeah, so about me, I was a system administrator for the past 3 years. System admin come tech support, and I used to work with clients via tickets and chats on their private servers. And 6 months ago, I joined a startup called Signians, where we help clients with AWS solutions. We architect for them solutions, and we build Terraform code for them, and we give it to them. I also love a lot of anime and TV shows. My favorite animes are like Jujutsu Kaisen or Demon Slayer and Horimiya. I also have watched a lot of TV shows. I sort of like a lot of TV shows. I'm also quite new to the DevOps world. I don't have much experience in all the areas, but I'm currently learning it. I also have a ton of anxiety and nervousness, so in case I stutter in the video, please don't mind that. That is just me forgetting stuff. Yeah, so what exactly is Terraform? Terraform is an infrastructure as code tool. That means it will help you write your infrastructure using code, and there are something called as providers that are created by the public, and public as in people who work with open source, and also there are official providers that are also maintained by people, and they are also open source. But there are some providers which are custom made or something like that. Basically, infrastructure as code tool helps you to put your code, put your infrastructure in terms of code, and allows you to build on it in a much better way compared to ClickOps, wherein you're in the console and you're clicking a lot of windows. ClickOps is good when you're starting out, so you'll be able to know what you have to create and how you have to create it and what options are required. For example, I couldn't directly just start with Terraform without knowing the things about EC2 instances, like what all are instance types and what all sizes are there for EBS volumes or security groups. How are they actually in the console. So it's always a good thing to start out in the console, or if you're okay with the code, you can also start out with the code. There is no one size that fits all sort of way. It also helps streamline your infrastructure. People have Excel sheets that you can use to sort of put your infrastructure on a sort of a master sheet or something like that. So Terraform also helps you, with that. When it's in a folder, you can just go to your favorite Git repository hosting, that is the GitHub, GitLab, or whichever one you prefer. And you can basically view the files, view the infrastructure that has been created. They also have, there also you can just put readmes, and so you can tell people that so and so folder, or so and so file does so and so thing. So there are a lot of there's a lot of ways you can document Terraform, either inside the code or by creating readmes. It also allows you to create infrastructure plans. What I mean by this is when you run Terraform plan, it gives you an output, which is a plan, and you can store that output as like a file or something like that, and you can run Terraform apply on it. So in the plan, you get to see all the details that are being shown by Terraform, things such as how to create, what will be created, sorry, and what will be deleted, or what are the options that Terraform knows about, and what will be in the state file after apply. So that is also a very good thing of Terraform. You can see what is being created rather than having an abstraction layer that you don't know what all things are being created for you. It also allows you to create graphs. Terraform graph is something that you can use to get like a graph of all the resources that are created. So you can get all the dependencies of what resource depends on what, something like that. So what exactly is a blast radius? Blast radius, I would say, is something that comes in picture when you have a lot of resources and you do an accidental deletion. Even though Terraform does give you an option to approve it, there are chances that you may go ahead and type yes, and just it so happens that your entire infrastructure, due to it being into one folder, you don't have it anymore, and fired. So basically, this blast radius is also when you have a security issue or you have a breach with one account key. This also can come in use there, wherein you can give different types of access by the access key IDs. So yeah, all the basic Terraform code always starts from this very familiar tree structure where we have a production folder, and in the production folder we create multiple files with things like ECS, CloudWatch, S3, variables, VPC, and we just keep these files in a single folder. This is good for starting out for small companies where where you have less than 10 resources or 20 resources. I'm talking about all the resources, like not subnets, route tables, individual resources. I'm just talking about resources in general, like RDS, EC2, something like that. This structure is good. It helps deploy your code faster, and you have all your resources. You don't have to reference them from anywhere. You can just use them in the same file. You don't have to use much of locals, nothing as such, and you're good to go. But soon time passes, and you have a lot of resources piling up, and you have different folders. You have UAT, you have testing, you have staging, you have production, and these keep growing. And once your organization grows, you don't have much time to go back to your old code and refactor it. It takes a lot of effort to refactor Terraform code and code in general. And this goes on, and you have long refreshes where just one small change leads Terraform to refresh everything all the states, all the resources, and yeah, this can get a bit time consuming, and it's not a good thing. For example, for me at least, I cannot wait for more than 5 seconds when something is happening, or when CI/CD pipelines are building. I need a different task to do, and this can take a lot of time. It keeps going, and you can get exhausted with it, because even one small error and you will have to do the Terraform plan again, the apply again. The simple thing that I am proposing is to split the folders based on the resources. For example, we have a non-production folder here. We have a network folder wherein we can define our resources such as our VPC, our subnets, private subnets. You can use a VPC module to do this very easily, and the VPC module will give you a lot of outputs. So these outputs can be accessed, by different folders using something called as a Terraform remote data source. If Terraform remote data source is not something that you wish to use, you can also use data sources, but data sources can get a bit too much, because you would have to define a data source for every little thing, such as subnets, private subnets, public subnets. Your tagging has to be correct in order to get these done. So in order to get to this structure, there are only few things required. You'll require a Terraform remote data source. For example, I use the S3 bucket as a remote data source. I've used locals because the module output that we get, they can be quite long when we are writing it in the code. It can cause a lot of line breaks, and it makes the code a bit lengthy and unreadable. So I prefer to use locals. I just create a file locals.tf for that folder itself, and I will shorten the name to a memorable name or a shorter name with proper meaning, and I use that in my code as locals. Terraform outputs. This is the most important part, I'd say. In order to get your code working correctly with another folder, you would have to basically be able to, correctly define the outputs that are required. You can also define these outputs as you go. When you find out a new output that is required, you can simply add it to an apply, and your changes are done quickly in another folder. As I mentioned, you can also use a data source. Data source can also help you with things like VPC IDs. When you are creating this backend the first time, I would suggest you can use a data source to create something like for a backend VPC ID or a bucket name, something like that. Whatever is required, you can use that. Terraform locals are, I've heard a lot of people say, like, do not use too many locals, which is right. It's also, something that nobody tries to use much during programming itself. But in this case, these locals are, to the folder. Okay? They are for a particular resource, and they are logically separated. So I don't see any, disadvantage in using locals here, and they are much more helpful because I just have them in a single file, and all the locals can be viewed by anybody, and it can be read and understood what is happening. Yeah, so after we create the backend, I usually create the backend first by using a local state. Okay, and then I do a Terraform init, and I migrate the state to the S3 bucket that I create. I know it is a bit of a manual step there, but that is what I have currently. So the Terraform file structure looks something like this. You have a non-production folder, you have a network folder where you create all your VPCs, you define your subnets, and you create private subnets, public subnets. So I use a VPC module. So the folder structure is such as the main.tf has got all the main resource related definitions, such as the VPC module where I give what I want, like a NAT gateway per AZ or no NAT gateway per AZ because they're quite expensive. Don't get me started on NAT gateways. I find them quite expensive in AWS, that is. And the output. So here, the VPC module comes with a lot of outputs. If you head over to the GitHub page and you just look at the VPC module, there will be an example with the outputs folder. In the outputs just file, I simply copy it, okay, and I remove any unnecessary, unwanted outputs that I don't require. And I simply keep them, so I don't have to sit and modify or define the outputs. All that I need are mostly there in the default example. Next is the Terraform.tf. In this, I define the provider. I define the remote data source, basically, from where I will request data or I will pull data to this as a read-only resource. There are also two files called variables.tf and Terraform.tf. Terraform.tf is something that is like a file that you can provide in your folder, and Terraform will automatically read the variable values from it, provided it is defined in variables.tf. So Terraform.tf is a file that you do not have to check to your GitHub repository. So it will be a file that you use during runtime, so it can be stored somewhere elsewhere. So yeah, this is about the file. The definition. So for example, in the Terraform.tf file or the provider.tf file, whichever you prefer, I start by defining my provider, the AWS provider, for example. Here. I define a backend that is a remote backend. So the key is basically where I store the Terraform.tf state. It is in a separate folder with Terraform.tf state as a file name. I also specify the bucket that was created as a backend. We set this encryption to true. This is my AWS profile that I have to keep specifying. And then I provide the region and the DynamoDB table and endpoint. The DynamoDB table and endpoint is for state log. For example, if you give a DynamoDB table and endpoint, nobody will be able to, do an apply when someone else's Terraform state is currently active. You can also separate the states. There is no issue as such, or the state log. So you don't overwrite anything accidentally, and it can cause corruption issues also. So that's it for the provider file, the Terraform.tf file. Next is the outputs. Okay, in the networks, I have now defined my VPC module. I have defined my subnets, everything, my CIDR block. And now I just want to create a simple output. It's a very simple setup right now. I really want to start by giving private subnets out. So this is a very simple one that I have created. This just gives me output of the modules that are the VPC modules that are created. So then I can simply, keep this in the same folder as a networks folder. Then, for example, I have a ECS cluster. So I want to use the data source in that cluster. So what I can do is I want to use a network data store. So I just create a data source with a type of Terraform remote state. And I just, use the network as an identifier. I specify my backend, the configuration, the key, the region, the profile, and so on. And this is the usual, writing of the Terraform modules, the Terraform backend that I want to use, the new one. I have not shown the provider definition here because of the lack of space and the slide becoming too long. So this is how I define the locals. If I want to use any locals, I can just take this local, set it as a VPC ID, private subnet, public subnet. And this is in another module. I have made a mistake. The file name. And this is in another module basically, where I can directly just provide the full name. As you can see, it's quite long. So locals come very handy in this case, where I can just say local.vpc, local.private subnet. So this helps me, reduce the long name and improve readability. Yeah, so that is how I define it. In case this is not completely clear or a bit confusing, I have also written an article about it where I have gone in more depth. But the whole point is that you can define your outputs in one folder and you can call them in another folder using the remote data source option that Terraform provides. Yeah, so these are the locals. And so, what are the advantages of this approach? If you ask me, it is basically separation of resources into logical, components. For example, I can have my backend in a separate folder. I can have my, network in a separate folder. I can have my ECS. Inside my ECS, I can have a folder for clusters. I can have a folder for services. I can have a folder for task definitions. So I can break down the code into many small pieces where in case I accidentally try to do an apply and I don't see, or it's a human error sort of thing. Sure, we can run it in pipelines these days, but most of the time, sometimes we do have to run it on a system. So it can also help with that. Accidental deletion can cause less harm because say you run it inside a folder which is a small subset of your resources. There is no such thing as we can prevent disaster completely, but some we can at least limit the harm that we go through or we face due to the disaster. So this can help with that. You can make changes much quicker and much efficiently. For example, if I had to update something in my ECS service, I don't have to wait for the entire refresh of Terraform to go through. So it's not Terraform's fault also, like the long refresh. And we have defined too many resources, and so this can help. The code also becomes a bit self-documenting. I can, give a code and I can map out a structure. I can tell somebody else to read it because it's in folders. So I can tell, what folder. I can specify a README per folder where if you're viewing it on GitHub, it will directly show like this folder contains so and so things. Plus the folders names are resources. So it is much easier to understand what is happening in the code. And of course, this is not a de facto method. Many people have told me to use modules over this, which is right. I haven't completely gone into modules since I haven't worked for quite few weeks on Terraform. I have not got a chance to explore the modules. So I would also, try to use modules more. Maybe when I learn it, I can find a better approach than this or something that helps. So I would say this also has a lot of repeatable code, and also you have to do Terraform init on every folder that you create. So you have to define a backend, a remote data source. A lot of repetitive code can be there. Variable files appears. You need to maintain it correctly. You need to make sure the environments, the folders in which they are all correct. You'll also have to maintain many variable files per folder or something like that. State files also have to be named correctly. In case you accidentally, put another state file's name because we tend to copy paste a lot. So that also can affect this thing where your state files you overwrite a state file. That also can be bad. Creating a new folder can get exhausting because we have to define a provider, we have to define the remote data source, locals, variables. So it takes a lot of time to just get to writing your actual code that you wanted. Luckily, I was able to automate this since we had a lot of repetition. Sorry, we had a lot of repetition on this. So I basically just wrote a bash script that created these templates, taking names from the arguments. But it's not everyone's thing, and nobody wants to sit and write bash scripts to automate something that can be done much better using some other kind of method. So this worked for me for a project. Hence, I submitted this, and this is like my first talk. I haven't spoken anywhere else. I try to write on blog on my blog, but Apart from that, nothing much. Yeah, so that's it for the day and for my talk. Uh, if you like to talk and you want to connect with me on Twitter or LinkedIn, you can definitely on LinkedIn. I'm just Leon Nunes. Yeah, that's it. Thank you for attending this talk. I would like to thank HashiCorp for letting me give this presentation. This entire presentation is also an article, and it can be read on bit.ly04arc. And my dev2 profile is dev.to mediocre DevOps. That's it. Thank you and have a nice day.
I will say this, we're all mediocre DevOps because ultimately we're all just learning and learning again and making the same mistakes just slightly differently, always advancing a little bit. And eventually we'll just do something else and bake cake. So with that, let's switch products a little bit and head on over to Bram Vogler, who's going to be talking about Nomad Pack in a 15-minute meal session.
Good day, good morning, good evening, wherever you are. Today we'll be discussing Nomad Pack in a 15-minute meal style like Jamie Alhoven. My name is Bram Vogler, and today I'll be your guide. So your cook, as you will. I'm currently employed as a cloud engineer at a small consultancy firm called The Factory in the Netherlands, and I'm also a Nomad co-contributor for 2022, as well as a HashiCorp ambassador for this year, which I'm very stoked about. And today I'll be introducing something called Nomad. Some of us might already know it, but I'll give a small introduction. Nomad is an amazing open source tool made by HashiCorp. It is built around dynamic workload scheduling. It can do anything from batch work. It can do containerized, which is an example we're going to look at today, but it can also do non-containerized applications or even VMs. The amazing thing is it has native console and Vault integration, some of the other cool tools that HashiCorp produces. Console with its service discovery tool and Vault with its secret management. You can do it with tokens, so you can have ACLs around it so that not everybody can deploy. And its jobs are written in something called HCL, the HashiCorp configuration language. And that's something we're going to zoom in on a bit more today. What does one of those Nomad jobs look like? In this case, I'm going to show you a simple lorem ipsum example. It's going to expose a Docker container on port 8080. It's going to randomly assign a port number, which Nomad can work out which one it is. And then it's going to link to 8080 inside the Docker image. And for this Docker image, we're going to use something, my custom-made lorem ipsum container at version 1.00. And it's going to bind this HTTP port that we've defined before. Now, you think that's all mighty fine. But if you come into a situation where you want to do CI/CD, it becomes quite difficult to do. Well, not difficult. The DSL wasn't built around people wanting to make this variable and using variables to inject this version. Because in your CI/CD, when a new version comes out, you want to bump this number. And before Nomad Pack came out, you would actually have to, do some set, grab, replace stuff to actually get this going or make it parameterized. But for a while now, HashiCorp has come out with something called Nomad Pack to actually make this easier. It's built on another open source project that was pulled into HashiCorp, but now it's going to be more tightly integrated with Nomad itself. So let's have a look at what's that going to look like. So first of all, we need to install Nomad Pack. Nomad Pack is still under active development, so you'll have to go to GitHub to the releases of this project. And I suggest at the moment you run the nightlies because the Nomad pack is under such active development that you're gonna miss out on cool new stuff if you don't use the nightlies. All right, so down to the asset list, you're gonna, in my case, I'm gonna look for the Darwin binary. I'm gonna simple click download. As it says here, because they're still in beta, there's not going to be in the homebrew installations or in the apt or yum repositories that you're used to. So in this case, my browser tells me it might be dangerous, but that's okay because I know where it's coming from. And actually, I already have it installed, so let's have a look what that looks like. It's tag preview number 3. That's pretty much the one from last night. And it has a simple, well, it's a CLI command, so you can also be able to show help. And it does two things, Nomad pack, which is it also allows us to do properly parameterized jobs, but it also taps into an ecosystem like we used to with Kubernetes Helm equivalent. In this case, let's have a look at what registries there are. And you'll find that Nomad pack comes installed with a default registry. So something that's curated at the HashiCorp GitHub organization. As you saw when you run it for the first time, it actually pulls in the latest state of the public registry. And actually it shows quite a few applications already. There's a lot of observability in there. But let's have a look at, for instance, the Hello World job. Ask for the Hello World, what kind of information that would show. Then of course I forgot to ask for what register. So I can. It tells us a lot here. It tells us the name. It tells us who's the author, what it came from, and it also explains us explains to us what kind of variables that are available in this job. So if we look at the job itself, this is the bit where Jamie says, here's one I did earlier. So I already checked out the community registry. And what does this look like? If you're going to have a look at the Hello World again, you'll see there's a README. And that's the list of variables that we've seen before. So this is what a normal Nomad help file of variable file would look like. Right? We have a job name. We'll have a variable called job name. Will have a description. It will have a type. And this looks very, very familiar to Terraform because it basically is. It uses the same DSL that I explained. And the bulk of the things that are happening is in these two files, the template files. One, the hello world.nomad.template, name.nomad.template is quite common to use for this. You'll see here that it is a job file that looks very familiar to what I showed in the PowerPoint, but now there's some bits that are templated out. The templating language Nomad pack uses is standard Golang template. So if you're familiar with that, it's very easy to pick up. So the things you would want to modify, you can very easily change into a Golang variable. In this case, my job name. If your Nomad cluster runs in different regions, then that's where you're going to go. And in this case, my example doesn't actually have a version, but this is why you would inject another version. But the most important or interesting bit is here that you can also integrate with console and make that optional. Also, now that Nomad's come out with their native service discovery tool, you could still write one job file and have users of your template basically decide whether they want to go full console or just want to go native. If you want to develop our own pack, you want to start building your own registry, which is since for a while now, Nomad has a function inside of it. Before you had to, I want to generate a registry. Let's ask for help. Of course, we need to have an output. I want to have it in my local directory, and let's be lazy and ask for my sample pack. HashiTalks. Let's be very imaginative in the name, and let's have a look what that generated for us. Oh, I did that wrong. Let's have a directory called HashiTalks. Change into the directory. Change into the directory HashiTalks. And run that again. Right, now we have a simple layout. We'll have our changelog.md, our readme.md, and I'll have a simple initial pack already. And if you open that, you'll find that it's pretty much the same hello world that we've seen in the public registry. You'd be surprised if it wasn't. So this template, you'll see it's the same job. And if you zoom in a bit more on the helpers, you can see that you can, without plugging your main template, you can template out other stuff, like setting defaults for names if none is given, or stuff needs to be white space needs to be stripped. All right, let's create ourselves our first pack. Then pack. Let's do foobar. And we'll see that in our packs we have another new job. It's called foobar. It will have a simple help, single line that will output to make sure that everything works. It will have a certain amount of default variables that you can build upon. As you'll find, it looks very familiar. What it actually is the hello world repackaged. If you want to develop more, you'll find that you can actually, from your pack directory, you can simply do a Nomad pack run and then local directory. And if you want to make it a bit more special, you can start adding variables. You can either use them variable by variable, or you can specify, if you're very lazy like I am, a vars.hcl file, which is something you can build up or commit into your repositories itself. It's very nice. If you want to, well, this you can now commit. You can save it to your own GitHub. In my case, I have one already. At the moment, my registry doesn't do much because most of the work I have been doing has actually been merged directly into the community registry. In this case, I can I can add my local registry again by doing Nomad pack per registry and give it a name. So it's going to go out into my registry and basically it's going to have more files. If you now do a Nomad pack registry list, you're going to see that it not only has the default registry, but also has my own little, very unimaginative hello world. If you've run it, if you want to kill it, it's a very simple Nomad pack destroy hello world. So far, that has been a fairly simple setup. But now, if you want to, for instance, when you are developing, it can be that you're going to get some errors back from Nomad, and then it's wrapped into Nomad pack, which is sometimes not entirely intuitive. You can now, since a little while, you can render stuff out. So you could always render it to screen. So Nomad pack render and then local directory. You see it renders your local. It renders the template into an actual job file, which you can review. And this is fairly new. You can also render it into a file that you can actually run, because now you'd have to copy and paste into a file or directly into the Nomad UI, but you can actually render it out into the local directory. You're still going to get the output, but now you're also going to have my little foobar job, and there you can see the rendered output. And this is now so you could actually just Nomad run this. And then you could see the actual output that Nomad generates. Especially when you're developing, this is very useful. Because sometimes, people make mistakes, so you're gonna get some weird outputs or broken outputs, or your job isn't starting. So you want to have feedback, and this is the new rendering to file feature is very, very powerful. And with that, I think it's my 15 minutes are fairly up. So I hope you enjoyed your meal. If you want to discuss more, you can always email me at bram@attachmentgenie.com. If you want to rant or yell at me on Twitter, it's at attachmentgenie on pretty much any social media out there. And if you want to look at this or any other slideshow I did, you can always visit me on SlideShare. And that is really the end of today. So if you have any questions, I'll be around in the chat channel.
Yeah, I can confirm that when you ask Bram a question, he will not make you feel stupid, no matter how silly your question is. He will help you discover the answer to it, and you will feel silly on your own afterwards. Having been there, definitely how it works. Next up, we've got Anna talking about up and running test with go-tfe, the module that's being used for the TFE provider.
Hi, my name is Anna Winkler, and I'm a software engineer at HashiCorp. I work on the Terraform CLI experience team, and today I'm happy to talk with you about how to get up and running tests in go-tfe. Well, you might be wondering what go-tfe is, or maybe you're here because you actually would like to run tests in go-tfe and it's been kind of a struggle. Well, this is our Go client for Terraform Cloud, TFC, and Terraform Enterprise, TFE. There are a few assumptions and prerequisites that'll help you in this talk. So first off, it'll help you if you're already set up for Go development on your laptop. I'm using a MacBook Pro, and all of the commands today will be for a Mac. There are similar things that you can do on other systems, and that's unfortunately out of the scope of this talk. I'm also assuming that you've already cloned the go-tfe repository. So you may have issued something like a git clone and then the URL of the repository there. Next, I assume that you've already got an editor for editing Go code. So I myself like to use Visual Studio Code, but there are lots of other editors out there that you can choose. And finally, you'll need access to a TFE or TFC instance. We need this to run the go-tfe tests because go-tfe is a library and it needs to work with an API for the tests to work. So if you don't have your own Terraform enterprise instance, what you can do is navigate to app.terraform.io and sign up for a free Terraform Cloud account. Once you do this, you'll be able to create a token that you can use to run tests. And now the tests. Here I'm showing part of our tests documentation from the go-tfe repository. So we can also navigate to this tab here where I'm showing the repository. So we do describe how to set up the environment variables. So the first thing we're going to need to do is to install env-chain, and I'll talk about that in just a moment. Next, we've got a helper script to set up environment variables, or you can set the variables up yourself using env-chain commands. There are two environment variables that are required to run the go-tfe tests. We need to have the address or the URL of a Terraform Cloud or enterprise instance to use for testing. And next, we'll need to have a token to connect to that instance. So let's first make sure that we've got env-chain installed. Env-chain is a tool that I like to use to set up environment variables. You can choose something else, and you actually don't need to use any tool if you like. But I found that it's pretty handy to set up the environment variables, since in this case, we need to have two. So if you don't already have it installed on your system, run brew install env-chain to install the tool. I've already done that on my laptop, so I'm not going to show you that part. Now, once you've installed env-chain, let's go over to my iTerm window here. I'm in the directory where I've cloned my go-tfe. And we've got a helper script here in go-tfe that helps set up the test environment variables. So it's called setup test env-vars. Run this script, gives you a little helpful information here. It also checks for the presence of env-chain. So if it doesn't find it, it'll tell you you need to go install it. So the first thing we need to think about is the namespace that we want to use for these environment variables. You might use something like TFC or even TFC prod. So whatever you want to choose is fine. We have a default here of go-tfe, but let's use TFC prod today. And now here, we'll enter in the address or the URL. And now we'll put in our token. And obviously, it needs to be a valid token. This one is just an example. Hit enter, and now there's a prompt for two of the other environment variables. These are not required, so we're going to skip them today and just focus on the address and the token. So I'm going to hit enter and skip GitHub token, and I'm going to hit enter again and skip GitHub policy set identifier. Great. So now we've got our environment variables set in that namespace. So if we were to run this command, and let's grep for the TFE one specifically, we'll see that these values are available in our environment. Well, now that we've got our environment variables set up, let's say that we found an issue in go-tfe. So I'm going to open up the code with my editor, and I'm looking at the organization tags integration test. So maybe we found something in the organization tags that we'd like to submit a pull request for, and we want to first run the tests. Well, this is where we can use what we just added with env-chain to run those tests. So we're going to say env-chain, and then the namespace that we just entered in, so prod. And now this is just like running any sort of test in Go. So we'll add verbose and integration for our tags, and then we're going to run the organization tags tests. So we'll hit enter here, and here we go. Look at that. So we can see that we ran all of these tests and they all passed. So that's great. Now, the nice thing about using something like env-chain is that we can set up namespaces for other environments. So for example, if you have a staging environment available to you, you can set up a namespace called TFC staging and run those same tests. And we see that those tests also pass. Great. Wonderful. And there you go. We're up and running tests in go-tfe. Thank you so much.
Now, my position on this is really simple. If it only takes you this short amount of time to get you up and running with tests, there's no excuse to not run tests and write tests for all the stuff you're building. Other than that, the TFE provider is a really great way to do stuff for Terraform. If you're running Terraform Enterprise or Terraform Cloud, you can literally use Terraform to terraform your Terraform Cloud, which can then terraform other stuff. There's a lot of fun in that. I mean, who doesn't like tongue twisters? For us, we're ready to head on over to a community talk from Scott McAllister from PagerDuty and some lessons on inheriting a provider.
Developing a Terraform provider is about creating connections. You're connecting users of Terraform with your platform, either a platform that you're of a company you're employed at, or maybe it's a platform that you rely on for your workflow so that you want to be involved with the project as well to make sure that the provider connects you to Terraform. But the development of that provider also connects you to those developers who are willing to help out, willing to get involved in the open source side of things. And so you make those connections to make sure that your provider provides the use to your users and also to the developers that are maintaining it with you as well. Now here at PagerDuty, our Terraform provider has maybe a unique story, or maybe it's a story you've heard before. But what I want to do is take you through that story, through our journey of our Terraform provider and how it started, how we took over for that development of that provider, and then also the lessons that we learned while we went through that process. The story of our provider actually begins back in 2016. There was an SRE engineer in Sweden named Alexander Hellbom. And Alexander had adopted PagerDuty at his company. And at his company, they were also using Terraform to manage all the different aspects of their infrastructure. So when Alexander got PagerDuty, the first thing he looked for was whether there was a provider in Terraform. When he discovered there wasn't, the next step he took was, well, are there requests for this thing? And so he found in the issues in the Terraform project that actually PagerDuty was a highly requested feature to be added to Terraform. And so, like every other good engineer, Alexander went into the documentation of the PagerDuty API, saw that there were the necessary endpoints to handle the different actions that he needed. And so then he dug into the development documentation for working on a provider and thought, I could do this. I could make this. So he dug into it and created a provider. And now back in those days, in 2016, providers were actually part of the Terraform project. So when Alexander was going through this process and when he was going through opening this pull request, he actually got everything ready and got to the point where he needed to click on the button to open the pull request. And he was nervous. He was a little shy to do it. In fact, he needed his fiance at the time, now his wife, they have a couple of kids. She clicked the button to open the pull request to add the PagerDuty provider to the Terraform project. And it's a good thing that she did, because the project now has over 40 contributors, hundreds of users using it every day, and they're making millions of API calls through our Terraform provider. According to HashiCorp, the PagerDuty provider is actually one of the top 20 most used providers in the whole registry. So all because of the actions of one person, really two, right? She was the one who helped him get the nerve to get it over the line and get it into the provider, or the provider into Terraform itself. We're grateful for that. And so are the many users who use the Terraform provider for PagerDuty today. Alexander continued to maintain the PagerDuty provider for years. Up until 2019, he was managing and developing and reviewing pull requests and addressing issues all on his own, and with the help of the other members of the community who also helped contribute to the provider. But he was the one kind of running point on everything. He was managing it and owning it. So in 2019, things changed a little bit. We as PagerDuty started to get involved just a little bit. I joined PagerDuty in 2019. And as a brand new developer advocate, I was excited, eager to impress. And so as I made the rounds, getting to know people around the company, trying to learn like what needed to be done, what did our developers need? The people who were using our product, what was the needs that a developer advocate that could provide? And I met this person named Julian, and Julian asked me if I was familiar with Terraform, just in general as a platform. And I said, sure, in concept, I understand its infrastructure as code and it provides a tool to allow people to do that, but I never used it myself. And he said, all right, well, we have a Terraform provider for PagerDuty. However, we have not gotten involved in the project. In fact, it'd be really great. There's this new feature on our API that we'd love to get into the Terraform provider. And it would be really great if the company was the ones who got involved. If an employee got involved with the provider. So when I got into this, I thought, all right, let me see what I can do. So I did the similar actions that Alexander did. Took a look at the documentation, took a look at Alexander's code and the rest of the code that the rest of the community put together in managing and creating the PagerDuty provider up to that point in 2019, and thought, maybe I could do this. I've always kind of wanted to learn Go, and this would be a great opportunity. In fact, I've heard a lot of folks, this is how they've learned Go, is by getting involved with Terraform provider development. And so while I was thinking about these things and planning and setting up my development environment, I decided I needed to make a connection for my own. And I reached out to Alexander and made a connection with him. And he and I started an email conversation that went back and forth and helped develop a relationship between the two of us, where he was able to trust me. I was able to trust him. He provided great feedback on my questions that I had about developing a Terraform provider. And so it was great to get that personal connection with the owner and the creator of the PagerDuty provider. So we got some information out of him, but we also wanted to give something back to Alexander. In that, we were able to bring him into one of our conferences. You see him here in this picture. He was recognized as the community champion in 2019 for our PagerDuty users because of the work he did with the Terraform provider. I loved recognizing the efforts of someone building open source software, but especially Alexander and how he built and maintained and managed the PagerDuty Terraform provider. So Alexander continued to work with me, continued to help me get started on developing this provider. And eventually, I was able to make my first pull request. And that was to add these event rules, this new event rules API endpoint into the Terraform provider. Adding the event rule resource was how I got started into developing the PagerDuty Terraform provider. And Alexander helped me go back and forth a little bit, but as he gave me feedback, he was always so constructive, so positive in helping me understand how to best do things and how Go worked and how the different libraries for working with Terraform providers worked. And he was telling me all through this time that he and I went back and forth, and he was teaching me that that's one of the reasons why he stayed involved with the project. He stayed involved and got involved because he had all this positivity that he gained from the community. People in the community would help him. They would encourage him. They would be positive in helping him understand how to best develop this provider for PagerDuty. And so because of that positivity, Alexander was motivated to be that positive with other people, and especially with others who are making contributions to the provider. So he and I went back and forth again as I made this pull request, and this pull request was the beginning of many that I had with the Terraform provider for PagerDuty. And it got to the point, our conversation finally led to a point where Alexander one day was like, so, you're getting involved with this. You understand what's going on now. How about, you take over? And I agreed, because let's be honest, PagerDuty should be responsible for PagerDuty's Terraform provider. What I also learned throughout this conversation is that Alexander had been supporting this Terraform provider that he created in 2016, but by 2019, he changed jobs, right? We all changed jobs. 3 years, that's not so bad. But within that time, he went to a new company, and that new company wasn't even using PagerDuty. Alexander was maintaining a provider he wasn't even using every day. How awesome is that? It shows to his character on how he respects the community, but also respects the fact that he takes pride in the work that he's done and making sure that the project continues on. So now that we're at this point, Alexander started to feel maybe this is time I can hand this off. Maybe I can hand this off to PagerDuty, or at least to Scott at PagerDuty, and it will be in safe hands, and it will be something that will be supported and continue on. So our journey that we had as we took over the provider, we learned a ton of lessons. I learned them specifically, whether it be code. I learned how to develop in the Go programming language. As I mentioned, it was a new thing to me, but also with process and culture and trying to get ideas in the minds of the people that I worked with, and to honestly sell, in a sense, the idea that we needed to support this Terraform provider, that this Terraform provider was vital to our users and ultimately to our company. So some of these lessons that I learned, I hope to share with you today so that you can understand what you can look forward to, what you can look out for, or how you can best navigate adopting a Terraform provider at your company. So the first lesson that I learned is I needed to get buy-in. Buy-in at a company basically means that you need to do that with data. You need numbers to let people know, why is this thing important? When I first got involved with the provider, I was telling my team, hey, there's this thing called the Terraform provider. And most of them were like, yeah, I know. And I was like, well, it's new to me. And so as I made a few pull requests, they thought, oh, that's great. He's getting involved with open source and with a project that's dealing with PagerDuty and helping our users and our customers. But then I started getting more and more involved. And so then I had to justify, why am I spending all my time on this Terraform provider? And then as I got involved, I started realizing, should a developer advocate like me, who normally doesn't work with production code, should I be the one responsible for this? I'm the single point of contact for this Terraform provider. And when things go wrong, I'm the single point of failure. So we need to have some kind of metric, some kind of data to let people know that we have users that are using this Terraform provider. So in that first pull request that I made, where I added that event rule resource, I also added one more line of code. And it's this line right here. I added a user agent header to every API call that we make, that the Terraform provider makes to the PagerDuty API. That user agent header identifies every call that's coming through the provider and allows us on the PagerDuty end to see in our logs, okay, now we understand how much traffic is passing through this provider. who is using this provider. We can now tie it to specific customers. We can tie those customers to dollar values. At the end of the day, we're a business, right? We need to make money to survive, to make our bills and all those types of things. So understanding the value, not only numbers wise, but dollars wise, made a lot of sense. And so we knew how much API traffic now was passing through the provider. As of last week, in the last 7 days from this point of recording this talk, we had this much traffic passing through our Terraform provider. 17.7 million API calls in 7 days passed through the PagerDuty Terraform provider. I would say that's a pretty valuable and valued tool that our customers are relying on. Our users are relying on Terraform to make sure that they can configure their PagerDuty instances. The next lesson I learned was that you need to find champions. No open source project can be done alone, because when you're making changes, when I see other pull requests coming in from the community, when I see issues that are coming in and opened by the community, I can answer those. As the maintainer, as the developer on the project, the lead developer, the maintainer on the project, I can address other people's issues and other people's PRs. But what happens when I have my own pull requests? I need to have people that I can rely on, that I can reach out to, that I trust, that also can help make sure that we have a solid quality provider. And even that the new additions that we put in, that those are solid and quality and keep the provider in a solid state. And so I actually recommend having more than one. You probably want 2 or 3, because here's the deal. You could create pull requests. And I noticed this in myself. I would create a pull request and I would ask someone to review that pull request. And then I would see an issue maybe a few days later and say, oh, that's a quick pull request or a quick code change. And so I make another pull request. If I keep asking that same person over and over to review pull requests on top of their day-to-day work, they might that might burn them out a little bit. They may not respond to my Slacks when I'm sending them messages anymore. So find a couple of champions. You can rotate around those requests. You don't wear out the people inside your company, because especially in the beginning stages, as you start adopting a Terraform provider, it's going to be something that folks are working on top of their regular work, because you're experimenting with this idea of, is this something that we should be supporting? And so during those phases, I definitely needed those people to help me review those pull requests, which leads me to my next lesson. And that's setting standards. Set standards for your provider, because as you develop on that provider, you're going to have lots of features coming in. You're going to have new fields added and new resources added. But make sure that if you set a standard, that everything should be tested, that everything should maybe have the same naming conventions, that those things are met as those pull requests come through. It reminds me of a recent pull request that actually came through, where this developer really needed this new field that was new on an API endpoint at PagerDuty. And they needed this field for something that was coming up. It was very urgent. And I knew that this developer knew Terraform. I knew that they knew Terraform providers. They knew how to develop in Terraform providers. And so I had an extra level of respect in the back of my mind that they pretty much knew what they were talking about. And so when they said, hey, I added this field, it's great, the tests pass, can you please merge it? And I looked at the code, and my initial glance at everything looked right. And I pulled the code down to my machine, because that was a standard that I set for myself, that when I review something, I actually run it, because I want to see how things run and make sure, just to make sure that it actually works. So I ran this code and I ran the test. Test totally passed. Everything came back green. And I thought, all right. So I made one more look at the changes on that pull request, those changes that they were proposing for the project. And I saw the change that they were making to the code and the resource. I saw the change in the documentation, but there were no changes to the tests. So this new field being added to this resource didn't actually have a test for it. It wasn't being tested. I think you can see where this is going. So I added that field to the acceptance test on the resource. And I ran the test again. and it didn't pass. Come to find out, as I dug into the issue a little bit more and I looked at the logs and looked at the code, I realized the whole functionality that was built in for this field wasn't working at all. And so I went in, and because I saw what type of field it was a little more complex than just a straight up string field, I was able to go in myself and make the changes to make the field work. But I also left that field in the acceptance test. Set your standards and stick to them. Even if you think, oh, these people know what they're talking about, you still want to make sure that each of your fields, each of your resources have an acceptance test testing each of those things. Not only so that when you add the new feature that it works right when I add it, but in the future, when there's other changes on that resource or other resources that are related to it, you have that test in place to make sure that this field is not affected by any of the other changes in the future. So it not only makes it solid now, but it future-proofs your fields and your resources as times go on. Another lesson we learned was about communication. This one could also be stated as setting expectations. When you work with a community of folks that are using your software, using a project that you're building and you're maintaining, they're going to come at you. The public is going to come at you with issues and pull requests that need to be addressed. As humans, we like to see movement whenever we have a concern with something or when we want something to be done. And sometimes when you're on the receiving end of those issues and receiving end of those pull requests, we might not have the bandwidth to act on things the moment they come in. But if we set a standard, we set an expectation for an amount of time that we're going to be responding to these things, maybe internally you can set an internal service level objective that in 5 business days you'll make sure that you at least respond to issues, or that you'll look at the pull request and respond to the pull request. You could even go as far as setting an external SLA. You could have a service level agreement stated right in that project that says, we will respond to you in 5 business days on these open issues, on these open pull requests. I've been told that that's actually a great way of doing open source software, is by having that open and honest expectation. Not only does it let folks know that you're going to get to this issue, it gives you 5 days for them to not reach out repeatedly and saying, whoa, they didn't respond to this last night. I'm going to ping him again, which just makes everything more stressed out. So find a time that works best for you and your organization, your bandwidth, and work with that. To be perfectly transparent, perfectly honest, for me, this is one of the lessons that I've learned, but I'm still learning and I'm still trying to do a good job of this one. I'm not great at it. I need to be better at responding to folks in a more timely fashion, but that's key when we're learning something, right? We know where we've done well and where we can still improve. This is an area where I can still improve. So those are some of the lessons that we learned while we adopted our Terraform provider. Remember, to get buy-in, and you do that with getting data. You want to gather data on your usage so people can understand the importance of your Terraform provider. Second, you want to find champions, multiple champions. That way you don't burn them out, to help you review pull requests that you create. Third, you want to have standards that you set and that you stick to. Stick to your testing or your testing standards or whatever standards that are important to you, to keeping your provider a quality provider that's stable and also easy to use. Fourth, you want to have a communication with your users and communication with your developers. Make sure you set expectations, communicate those expectations, tell them that you can get to this in a certain amount of time, or it might not be in that certain amount of time. Maybe it's in a week or 2. But if you have that expectation, folks are generally more happy when they work with you there. So as you've learned today, our Terraform provider at PagerDuty began in 2016 when Alexander, a member of the community, created it and continued to maintain it. In 2019 was when I came onto the scene, when I saw that there was a need for a Terraform provider to be supported by the company that it was connecting to Terraform. It wasn't my primary responsibility, so it was something I did on top of the other work that I had to do as a developer advocate. And now, in 2022, we hired our very first Terraform provider developer. So we have a developer who's going to be focused on the Terraform provider 100% of the time. All of his energies will be focused on making sure that the pull requests are reviewed, that the issues are addressed, and also that new features on the API that come through the PagerDuty API are being added to the Terraform provider for PagerDuty. So this is our journey that we've taken. We hope that you've learned some of the lessons that we did, and that by learning from the lessons in this talk, possibly you may not hit the same little speed bumps that you do in your journey. My name's Scott McAllister. I'm a developer advocate at PagerDuty. I hope, as I mentioned, that your Terraform provider development experience is as learning and as fun as mine was. Thanks for watching, and have a great, wonderful rest of your day.
Thank you for sharing that, Scott. This almost feels like it's coming full circle. We had Alex at the first HashiTalks DACH in 2020 as a speaker, and he briefly mentioned the PagerDuty provider, but we definitely lacked the whole background story here. Pushing a pull request live is scary. It's all about having a good experience here, right? And making it comfortable for those that want to contribute to make it a better experience. So I think with that, let's bring on some of our guests from the Terraform developer experience team. Dave, Brian, Vishnu, please join us. Nice shirt there, Dave.
Oh, yeah, nice shirt. Thanks for having us.
I love it. Thank you for joining me. So for the folks that don't know you, and I know, Brian, you've been here at last year's HashiTalks, but quick overview, what does your team do?
Yeah, so our team really is here to help folks like progress in their journey with, developing Terraform providers. So, we're here to help build the ecosystem, make development easier for folks, solve, that problem space, whether it be, encouraging folks to, engage with their communities like Scott was talking about there, or, helping folks with the actual code and testing implementations. We're here for all that.
That is a great mission to have. So what I'd like to do is get everyone 30 seconds to introduce yourself, because ultimately teams are made up of real people. I know, Brian, you've been here before, so you'll go last. But Vishnu, why don't we start with you? Some technical issues with your mic there. Possibly fix this now. My lip reading is not that great, but let's switch to Dave.
No.
There we go.
No.
Yes.
Yeah, we can hear you. Go for it, Vishnu. All right, I'll go now. I am Dave Parfit. I manage the Terraform developer experience team based in Buffalo, New York. What else can I tell you? I don't know. I enjoy working on the DevX team. It's pretty awesome.
I like that you're very objective about that.
Yeah.
Vishnu, how's your mic doing?
What about now? Can you guys hear me?
Yes.
Great. Sorry for the inconvenience. I recently joined this team as a product manager. I'm excited. There are a lot of new things which we are trying to accomplish. The one thing is the framework, but we're also trying to make sure how can we improve the developer experience for building the provider and the provider development. That's in parallel with what we want to do.
Brian, welcome back.
I'm back. I know you're stuck with me again. So yeah, hi, I'm Brian Platt. I'm based out of Philadelphia, Pennsylvania in the US here. I've been at HashiCorp for over 4 years, so I guess I'm considered a little bit of an old timer around these parts, but still enjoying it, still loving it, and excited to still be part of the engineering here. So.
With lots of years comes lots of experience. I think that's actually great. You've had a storied career here, working on the AWS provider. We've had a lot of community office hours together, so I'm excited to see what you're doing next. So I'm actually curious. A year ago, you presented something. Take us back in time.
Yes. So
What
about
can
a
we
year
talk about?
ago, the team was announcing kind of the very beginnings of what is now called the Terraform plugin framework. So this is kind of like a next generation of provider development. It's kind of, think of it as like kind of a reimagination of like what the provider development experience could be. So taking all those things that maybe aren't familiar in Go, like type assertions and like all these other complicated coding things that were kind of applicable back in the day when Go was first forming and Terraform was first forming. But taking a new look at it and saying, oh, can we provide like a cleaner, more, provider developer friendly experience on top of what we're doing today. So that's where the framework was born. So we talked about that a little bit last year. And yeah.
That was actually a great session. We'll have the link for that up in a second. But so let's not dwell too much on the past. What's coming up?
I think I'd love to like ask that of Dave here, like our fearless leader.
Oh, fearful. I don't know. Yeah. So I think, let's see. We are focusing quite a bit on the plugin framework. We're expecting to release it in GA later this year. So that's like the biggest thing that we have right now. We've actually scaled up the team, added a few engineers from around the globe. Ivan DiMarino, Ben Bennett, Selena Goods, in addition, who has joined us recently. So we're very excited about that. We're doing some work on refreshing or uplifting some utility providers. So Random, HTTP, and TLS are getting some attention. They're moving over to the framework. So those will be released sometime soonish. I don't have exact dates. Let's see what else. I think that's it for like the big stuff. There's a lot of small things, but I can't remember those right now.
It's actually a great call out because the utility providers, people like to think of them as the small ones that don't do much, right? But once you start using them, like you can't live with half the features they offer you can't live without half the features they offer. It's been a long day. Forgive my mispronunciation there, because of the amazing opportunities they unlock. So question for the audience, well, actually question for you, but I'm sure the audience has their own idea for this. Which one is your favorite utility provider to work on?
This is a question for me, you mean, Kareem?
For all of you, actually.
Okay.
I will put all of you on the spot, don't worry.
I just want to say the random provider, I actually haven't touched it, but I make so many jokes about like, the test should be random. We should release on like random, dates and all that. So more just because it's just fun to make jokes about. Well, I'm not making fun of the software itself, but I like the randomness of it.
And there's some very nice pet names in there. Yeah, I've definitely used that to generate lots and lots of good names.
Yeah.
Vishnu, which one's your favorite?
For some reason, I like the HTTP providers because the reason we are working on that and fine-tuning those things. There are a lot of improvements with what we are trying to achieve in these days. So for those reasons, I like HTTP for now.
It's beautiful. Brian.
Yeah, so Dave kind of took my thunder here. I always like to say that the random pet resource in particular is one of my favorites, if not my favorite. But if I had to pick another provider, the time provider, because the time provider lets you do some really interesting things, like set up rotations of things automatically when you apply often and do some like interesting things in that regard, as well as like fixing some like interesting problems that you can have when you're like using the timestamp function and things like that. So I kind of like the time provider myself.
And you can probably use it to calculate time zone offsets between you and your colleagues. We're definitely keeping this serious here. I'm truly sorry for that. We try to work in a few puns ever so often. So let's talk about maybe testing framework features. Who's good for that?
I could definitely talk about that. So, we talk a lot about the framework and some of the development that's been happening there, but there's a lot of provider developers and an ecosystem that exists today. Folks need to be able to test these providers that they're writing, so hence the testing framework being a fun thing that folks use. This allows you to sit there and say, hey, I want to make sure that like a full create, read, update, delete kind of lifecycle works for my resources, depending on XYZ configurations. It's nice because you can just give it a real Terraform configuration. It goes and applies it via Terraform CLI, like Terraform apply command, that sort of thing. You can write checks in there that make sure that, hey, I want to make sure that this attribute has this value or this regex of a value, that sort of stuff. And all kinds of good stuff. You can actually tell it to, hey, I expect an error to happen here. Great. Sometimes you want to check for that kind of thing. But, it's one of those areas that like, hey, cool. Like there is stuff actually still happening in that space. For example, we had a community contribution that happened for adding JSON configuration support to the testing framework, which is really awesome, actually. So especially for folks who may or may not be looking at some more additional automation capabilities with the testing framework, that's a great example. Hey, maybe you can auto-generate some of your Terraform configuration in there, and it'll just work like a normal configuration would. Another really cool thing that has been recently added is that provider installation used to be per test case. So like,
I think we lost you there for a second.
Froze, yeah.
So this is a beautiful cliffhanger. So provider installation used to be per test case. And then, Dave, finish the sentence.
I cannot finish that sentence accurately anyways.
Well, in that case, we'll let Brian know that we're having some trouble there. But I'm curious, while we figure out how that sentence will continue, Terraform has been around for a long time. Lots of people are on different versions. We're currently, I think, on Protocol 6. We had Protocol 5 until a while ago. But of course, if you're still on an older version, you're still on Protocol 5. What are we doing in that regard in terms of working things in?
I can talk about that a little bit. Although I don't know like the lower level details. Hey, Brian. We're talking about Protocol 5 versus 6. So like the framework originally only supported Protocol 6, but there's been a lot of work recently that's super awesome that you can use Protocol 5 now. And I think the only big difference between 5 and 6 is 6 is supporting nested attributes instead of blocks. So correct me if I'm wrong, but yeah, so if you're using the framework, you can actually target 5 or 6, which is really cool. All new features will go in 6 moving forward. Yeah.
I think that helps. Brian, you left us on a suspenseful cliffhanger.
I know. Sorry. I just wanted to make more drama for this. Dramatic gopher. Turning sideways. Anyway, would you like me to finish where I was chatting about? Okay.
Yes.
Great.
I think we would very much like to know.
Perfect. Yeah. So I was talking about the testing framework and some new capabilities that we had. So one of them being that you can now do provider installation or usage based on each test step rather than once for the whole test case. This allows you to do like state upgrader testing, or I just want to verify that if I go from version 1 to version 3 of a configuration, a provider behind the scenes, like nothing weird is going to happen. So it's super neat that folks can now, do that sort of thing.
That is definitely neat. So we talked a little bit about utility providers, the SDK. People often think getting into building a Terraform provider is really, really hard. And I know at the HashiCons, when we run the How to Build a Terraform Provider workshop, they're usually sold out far in advance because so many people want to learn how to build one. Goes to show that the registry currently has, I think, almost 2,300 providers published there, with probably thousands more on people's GitHub repositories, not ever having seen the light of the registry. When you start building a provider, what's the one thing that you would tell somebody who's starting today and hadn't had a chance, like, to have the experience that you have? What's the one thing that you would have liked to know years ago?
Yeah, I think from the beginning, understanding Terraform conceptually can be a little bit interesting if you've never dealt with infrastructure as code. So, taking a peek at like understanding the concepts of like Terraform itself. Hey, what is supposed to happen during a create, read, or update or delete, and those sorts of things that would kind of affect the way that I should interact with my third-party vendor service, whether it be an API or some other database or something for a Terraform provider. So understanding some of those like initial Terraform concepts, I thought was like really helpful to. I gradually learned it over time, and I found out, yeah.
I think that makes sense. It's often, I think Scott was saying this or explaining the story of Alex very nicely, asking your partner to actually hit the submit button because there's such a mental hurdle to these things, even though you might totally be capable of writing the actual code. So I know that your team is making this experience better. Let's say I'm a user who's writing Terraform providers. And usually you start out with one, but let's let the hubris of the traditional engineer talk, and we'll start out with 3. How do I get feedback to you?
So yeah, our team has a few feedback mechanisms. If you're working specifically with a project like Terraform plugin framework, for example, there's a GitHub repository and there's a bug report or feature request form in there. If there's more question type things, HashiCorp Discuss is a great place to reach out. Some of our folks are active in there, paying attention, and trying to make sure that folks are getting their questions answered as best we can.
I think we'd like to do. I think we'd like to do more community office hours in the future as well, maybe periodically.
I think we'd love to hear from that.
Yeah, we'd like to hear more feedback on documentation and tooling and other tools that we could build to assist developers.
Definitely.
And just making sure we have the link up in the lower third. If that's too much for you to type, just hit up discuss.hashicorp.com and scroll through the list of topics. Also a great place to ask other questions. Doesn't have to be plugin SDK related. So let's talk about future projects. I see a lot of talk happening around generator providers and other things. What else do we have?
I mean, that's in the initial stage. I mean, we are trying to analyze what actually the developers needs. We're trying to get more and more feedback from the actual practitioners and the users, so that we can build our roadmap. We've been exploring some of the ideas about building the provider generator kind of thing, or supporting other languages. Right now, all the providers are based on Go language. So I want to see what are the other things what we can to provide as well. As I think Brian and Dave mentioned, the team is new. We want to make sure that we mature the framework and we build the tools and the documentation better for the user, so that we provide a better experience for the developers. That's the whole idea for now.
I think that's a great mission, and I trust that this team will get that done. So, as we're coming up on the end of our session, I'm curious, what's the one provider you wish would exist? I'll give you an example. For me, it's really simple. It's a Domino's provider with international support. But I'm also happy to take more serious answers.
Yeah, go for it, Dave.
I don't have a serious answer. I would like a time management provider that I could provision my day, but not through Google Calendar or anything like that. Yeah, I don't know. I have a weird time management system, I suppose.
I mean, there is a Google Calendar provider, and there's one for
Yep.
Asana. So I feel like, throw in a little random there.
That's my day.
It could be very interesting.
Yep.
Vishnu, what about you?
Probably for some kind of songs. I know we have some providers for Spotify or something. I want to build something as weird as that and see where it goes, because I think for all the products there is a limitation where we can do, but here I think we can build providers for many things, right? If you think about 2,300 providers, pretty much it started for cloud and for the infrastructure. Now it has got provider for many use cases. I think that's the beauty of it. I'm still exploring. I myself am trying to build provider and going through the whole journey. It's wonderful.
I'll take one for Apple Music, just so we have both, like major music services there. Yeah, I mean, it's important, like whenever we have HashiConf, the events team comes up with beautiful playlists, and I'm an Apple Music user, so yeah, I have to use some tooling to get the songs into the right service. So you could help me a lot here. And I'm sure, people would use that. I mean, think about it. Randomly generated playlists based on pet names with a time offset, so time zones are no longer a problem, all through the beauty of Terraform. There's at least 2 startup ideas here. Brian, what about you? What's the one provider that you are missing?
Honestly, it's kind of funny. Back when I was working on the AWS provider team, the teams that all manage the Azure provider, the Google provider, and the AWS provider hang out a bunch. And we always used to joke that we would go to these service providers and say, hey, can you please give us an API to go get fiber dug up to our houses? So it would be really fun to test it, because we would just submit the request for our house and fiber would just show up. So yeah, in light of that, I'm actually getting some solar panels investigated to see if we can put it on our roof. But yeah, it'd be awesome if I could go to my solar company and just be like, hey, can you just pop some on there? That'd be wonderful.
Yeah, the Terraform destroy for that one might be nice. Just make sure get the tax benefit.
I mean, I guess you consider that destroying the environment at the same time.
Yeah, tricky area here. Let's get back to talking a little bit more about other things. So one of the questions we hear at a couple of events ever so often is, hey, do I have to write my provider in Go? And I know at one point we answered this with, technically you don't, because it's gRPC, and if you want to go through the hassle of figuring it out yourself and build a shim around it, then you can write it in anything you want. Is that still the best answer?
I would say for now it is the best answer. Sometime after we release the framework 1.0, we're going to start thinking about that. There's a lot of really interesting projects out there that we found using all kinds of languages, C#. There's some JavaScript or TypeScript stuff, Rust, you name it. So we definitely have to think about how we can go about it generically, or make a full-featured. I don't want to say too much. I don't want to promise that we're gonna do any one specific thing, but we're gonna start thinking about it, and I don't know. I'm pretty excited about that type of work. So
once it's on video, people hold you to deadlines even if you didn't mention them. So that's very wise.
Yeah,
I think what I've learned over the past years is that we have a habit of not releasing too early because it would serve nobody, and we'd rather release when the time is right. So I'm very excited about this answer.
Cool. Anybody else want to add anything in there?
No, I think you summarized it pretty good. Yeah.
Cool.
Nice.
Although I might prioritize the Vim script provider framework first. So sorry, I had to throw that one in there. This team, we have a lot of fun. So
you're going to have to expand upon that a little bit for those people that use real editors.
Oh,
sorry, was I not muted?
No,
go ahead. So Vim script.
Oh, maybe eLisp. We'll see.
I see your team does the like the video outage just as you're being asked difficult questions. This is a good trick.
I have no idea what you're talking about.
All right, so I think we'll definitely have you back for more community office hours, more traditional ones. Probably start off in August, given that July is almost done. And you'll just join us on YouTube. So for the audience that's currently watching and will be watching these recordings in the future, if you've joined us for our office hours, you already know what it is. If not, it's your chance to talk to engineers, project managers, and product managers, and engineering managers about the tools that you work with. You can ask the difficult questions. You can throw some, curveballs in there. We'll try to get you an answer that's useful, and we'll take your feedback. And one thing that holds true for all of our products, we'll take your feedback and we'll do something useful with it. Doesn't mean that it will show up in next week, Thursday's release, because sometimes good stuff takes a little while. But whatever feedback you give us, we'll take and process. With that, we are at the end of day one. And I know I can hear people sighing from the distance because, well, last year we did this 18 hours in one go. We learned from that. So we're going to continue tomorrow. Same starting time in whatever time zone you're in. We have pretty fun program also for tomorrow. I'm very excited about. I think Eastern time we're starting at, I want to say 5 p.m. That is definitely Amsterdam time, 11 a.m. Like I said, use Terraform for time zones. Humans are not the right choice for that. Good content around Waypoint, Terraform, well, and some other things that I don't want to spoil. And just like today, our last traditional session will be a culture talk that you definitely do not want to miss out on. So with that, Brian, Dave, Vishnu, thank you for joining for the initial DevX office hours. We'll have you back in the future. And to our viewers watching on YouTube, on LinkedIn, thank you for joining us. Thank you for joining us for the recording, also very important. Have a great rest of your day, evening, and morning. See you tomorrow.